Okay, thank you so much for responding. I'm Shahzawad. I'll be acting as your IGCSE Maths tutor today. I've given my IGCSE and A levels a few years back, around 2 to 4 years back, and I've been tutoring maths since. And we are from Cambridge Vantage, a tutoring agency who's trying to conduct workshops for you guys so that we can help you understand the requirements that Cambridge usually sets for the students. And we are here to explain the pattern of mark schemes or what the mark scheme actually expects from you and how the students should be answering in order to attain the full marks. Okay, I'll be screen sharing in just a moment. Please confirm if you can see my screen. And I'd highly encourage you guys to actively participate with me. If you have answers to give, please give that. I want you to solve the paper with me, since you can see that the time slot that I've allocated today is for 2.5 hours, and the paper should take 2 hours. And with all full honesty, I'm telling you that if you practice enough papers, you would be able to solve the paper within 1 hour 20 minutes or 1 hour 30 minutes as well. So what I want you to do is try to solve the paper with me today, and wherever you get stuck, you ask your questions. I'd highly encourage if you ask your questions by opening your mic. But if you're not comfortable doing that, you can always drop a question in the chat box, and I'm gonna get back to that immediately. Okay. Um, with that being said, let's just start. You can also see my screen, right? Can you please confirm real quick? Can you all see my screen? Okay, thank you so much. Um, right off the bat, I believe all of you will be sitting for IGCSE, since that's the paper that we're doing today. You might already know that the paper 2 is non-calculator, which means that this paper can't be, you won't be allowed to even enter with the calculator in the exam hall. But that's not going to be a problem, because all the questions in this should be able to be solved without a calculator. So even if your answer has something like pi or roots, then your answer is also expected to be used in terms of pi or roots. So you won't be required to use decimals or anything. So it's gonna be okay. And I'm gonna walk you through the entire paper, and you're gonna see how we don't need a calculator for this. Okay? Give me just a second. So the first thing we are gonna see is a subject code. You might notice that the subject codes are different for every single subject. Yes, Arjun?
Which past paper is this?
Sorry, this is May June 25, paper 22. Okay, this is IGCSE Maths paper 2, the very recent one from last year of May June. We're doing paper 2 and we are going to be solving for the entirety of 2 hours. Okay, I'm going to walk you through the entire paper. Does that
Okay.
answer your question?
Yes.
Okay, thank you so much. Please interact with me. No question is going to be smaller. Every single question is going to be significant. So whenever you feel stuck, or whenever you would like me to repeat something, or even if I'm just inaudible, or there was some internet connection from your end or my end, please let me know, and I'll be very happy to repeat myself. Okay. So like I was saying, let's start off with the paper instructions. And before we start the paper, I'm going to go immediately to the mark scheme and show you something. Okay. So this is honestly just an advice. It's not like if you don't attend all the questions, you're gonna have a -5 or anything. You're only gonna lose marks for the respective questions. So your errors will not be carried forward to another question or anything. So this is just an advice. Use a black or dark blue pen. You must know this. This is also not a requirement. This is just a pencil. They are giving you HB as a reference. So there's that. It's not that you're gonna lose marks for using any other pencil, or your examiners are not gonna check which pencil you're using. This is obvious. Your name is literally your legal name, your center number, and your candidate number. Since I believe this is the first time you're sitting for the exams, these will be provided to you by the if you're sitting as a private student, this will be provided by Cambridge directly. And if you're sitting through a school, then your school is going to provide you both the center numbers and the candidate number. At the same time, I believe that these both informations will be provided to you on the table that you'll be sitting in. So regardless of which hall you're in, or whichever examination center you're going to be sitting in, the table in front of you is going to have both of these informations along with your name and everything. So be very careful regarding this and regarding this, and you should be good to go. Okay. Uh, this is obvious. I believe your school also uses this practice that you are not allowed to use any correction fluid. If you get any answer, or if you have to cut something, just cut it normally with a straight line. Okay. So I have suppose 5x plus 3, just cut this off like this if required. Okay, this is very important. If you bring a calculator and if at any point you are seen with a calculator, your paper might get cancelled for this because this paper is strictly non-calculated. Okay, so this is very strict for paper 2. Make sure before you enter the exam hall that there is no calculator or phone with you, because your paper might get cancelled otherwise, even if you are not seen using the devices. Okay, so be very careful. Tracing paper, I hope you guys know what a tracing paper is. You're going to be using it for multiple questions in this paper as well. Tracing paper is something that they give you or you can bring from home as long as you get it checked by the examiner. So this is a transparent paper, a very thin sheet of paper that you will be using above the paper, and then you can mark things on that tracing paper to get the answer that you might need. I'm going to be showing you how to use it, though it's going to be a bit hard because I'm doing it online. And this is very obvious. The reason that they also require you to show this is because since it's a non-calculator paper, if you have very large equations and the very next step is just writing the answer, they might assume that you are copying it from someone or you have used some other sources for getting your answer, and that is not allowed, obviously. So the questions that have like 3 to 4 marks, if you just give one line in the very beginning as the forming equation and then you write your answer directly, you will be losing the method marks for that. Yes, Arjun?
Yeah, I'm trying to find the past paper, but I can't really find it right now.
Okay, so what I want you to write is 0580 IGCSE Math
IGCSE Math.
S25. This basically refers to summer 25. Okay, so if I were doing a paper from October, November, this would be W25. Does that make sense? And as you might know that there's another type of paper which is from February, March, that is referred to as M25. M basically refers to March. Okay. So I want you to search IGCSE Maths 0580 IGCSE Maths S25 paper 22. Okay. Let me just give you a link. Let me see if I can find it for you in 0580.
Okay.
Did you find it?
No.
Oh, wait. Give me just a second. I'm searching it for you.
Hold on.
So, you're all sitting for paper 22, right? If I'm not wrong.
I'm sorry, what?
You're all sitting for this paper specifically, paper 2 too?
Yes.
Yeah.
Lovely. I sent you the link. Can you try opening the link and see if this works?
I'm checking. Yeah, I got it.
Okay, thank you so much. So let me break this down further. This part is basically your subject code that you will see for all your other subjects as well. It's unique for every single subject. So if you did not know, IGCSE offers multiple types of maths. So your variant, the one that you are sitting for, is called 0580. And you'll see that there are other types of mathematics that IGCSE offers. And those are basically covered in different regions throughout the world. So in, let's say, the Indian subcontinent, they might be sitting for another type of paper. In East Asia, they might be sitting for another type of paper. So there's that. That is how the subject code works. And it's fully dependent on what your school prefers or what the people in your region usually sit for. So this is the subject code. The first letter here, the first letter refers to the paper number. Paper number. So this is basically IGCSE 0580 paper 2. Okay. The second letter here, this color coded with a different color. Nope, does not work. So the second paper is basically the variant. So during the summer and the winter, there are 3 variants for each paper. And during February, March, there is just 1 variant for each paper. So you're going to see that when you search for summer, you're going to get 2-1, 2-2, 2-3. These all refer to paper 2, and these refer to paper 2, variant 1, variant 2, variant 3. That is basically how it works. There all of them have the exact same syllabus, but they have just different papers for different students. Okay, so everyone in your exam hall, and I hope everyone in your country as well, are going to be sitting for one variant, but other people from other countries, they might sit for other variants. That's basically how the variants work. Okay, so before I get to let me just go to the formulas real quick. These are all from the chapter of mensuration. I believe you know that. These are all from the chapter of, or more commonly known as area, perimeter, and volume. I don't think any of this cover perimeter formulas, area, perimeter, and volume. This should only cover the areas and volumes, and the perimeter are just summation of all the sides, right? So I hope we all know that. You can see that the A's are all the areas, the V's are the volumes, and the C is circumference, as also written here. This is basically the length of this entire circle. That's basically what the circumference is. So these are all the formulas. This is the quadratic formula for this equation, solving for x basically. I hope you also know this formula. And lastly, these are the trigonometric formulas that you might need. This is very important. The cos formula, the cos theta formula is very important. Okay. The more common version of this formula is basically cos theta is equals to a square plus b square minus c square divided by 2ab. So this formula is also very commonly used. It's basically the same formula as this, but in this one, they're basically searching for one side, and in this one, they're searching for the cos theta value. So these are the two formulas that you have to understand. And this is the area of a triangle where, let's say, this is side A, this is side B, this is side C. So the angle here is basically the opposite angle of side C. And the way they formulate this formula is basically they take the two sides that make up the angle. So since A and B, they make up this middle angle, I'm going to say A, B, sine C. This C refers to this angle since it's opposite to the side C. Okay? So that is how this area formula comes to be. And this is the trigonometric ratios. This is known as the I think sine formula. If you search this or if you look at how to use this, you're going to get a hold of this formula as well. The best way to learn the formulas is by solving a couple of maths for each formula. There is no point in memorizing formulas if you don't know how to use the values. And for IGCSE level, I believe almost every single question is going to give you the values directly. And all you have to know is how to implement those values and plug those values into the formula. And that's basically how you get the answers. So that is all for the formula sheet. These are very useless unless you've already used these formulas before. It's very hard to see this for the first time during your exam and then try to use these formulas. So a huge advice would be to go over all of these formulas at least once, and you know how to use each of these. Then in the exam hall, these will not be new to you and you'll have gone through this before. Okay. So for any questions, if everything is okay, then we can go to the mark scheme and I'll show you how the marking is done. Does anyone have any questions? You could please raise your hand if you have any questions. Okay, wonderful. So let me just go over something real quick from the mark scheme. So every time you solve a paper, you're also going to open the mark scheme and you should be taking your answers. This one is for A levels. It's the same marks. The first couple of pages are the same, so I'm not really bothering to open the IGCSE one. The mark scheme is obviously specific for every single paper, is unique, but the first couple of pages that they define the rules for solving this paper, and the rules are going to be consistent for everyone. So these parts are specifically directed towards the examiner who's going to be marking your paper, not for the students who are sitting for the paper. So I recommend that after the class you search up an IGC, or I can just give you the link for that as well. Give me just a second. I'll provide the link as well so you can have a look at it after the class. Okay.
Mhm.
Okay, so I have provided the mark scheme as well in the comments. So you can have a look at it, and strongly recommend you to read the first couple of pages just so you understand how your paper is going to be marked. Okay. With that being said, there are few things that I explicitly want to cover just so you know how your paper is marked, because I feel like a lot of tutors and a lot of schools as well, they don't think that this is important for the students to learn, and they only expect the examiners who are going to be checking your paper. They only want these people to go through this. So the way your paper is marked, and you're going to be seeing these very, very often in your paper. Let me just show you an example. See this B2, 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 and then there is more. There's M1 here, there's DM1 here. So these are basically how you have to derive that the mark is distributed in this way, or like the examiner expects me to write these words or these lines in order to get the full mark. So you really have to understand the mark scheme before your exams, so you know that during your exams, even if you know how to write the answer, you must also know that how the examiner expects you to write the answer, or how they expect you to get to the answer. Okay, so I'll just be going over these very briefly. The M stands for the method mark. Okay, so it's awarded for a valid method applied to the problem. You can just read through this as I explain it to you. So these are awarded for using a correct method. Crucially, you can also get an M mark if you make a calculation error, as long as your intent and process is right. That's a very important thing to say, that even if your answer is wrong, but the formula that you use and the method you chose for solving this math, if the method was correct, you're going to get this M1. You will lose the mark for your final answer, but you will get the mark for your calculations, which is why it's very advisable that whenever you write an answer, you show every single step, so that even if your answer is wrong for any calculation error or any mental math error, since your workout was correct and since the method was correct, you're going to get all of those method marks. So it's very important that you show every single workout. Please read through this. It's basically the exact same thing that I just described. But yeah, the problem with this is you usually cannot get any subsequent marks if you don't earn the M mark. That's basically saying that if you chose some unorthodox way and you get to an answer without showing the method for it, there are times when you will lose the marks for the answer as well if you had not shown the method mark. So there are times when the method is very, very crucial, and it's mandatory to show that I reached the answer using this method, because there is no other way to write the answer mentally. So Cambridge is just going to assume that you copied it from someone else's paper, and you'll lose the method mark and the answer mark as well. So this is very important. The second is the accuracy mark. The accuracy mark is basically awarded for the correct answer or the immediate step after the method mark. So if you wrote the method correctly, if you wrote the formulas correctly, and you plugged in all the values properly, and you got to an answer, you're going to get both the M1 basically referring to 1 mark for the method, and then the A1 basically referring to using the method correctly and getting the correct answer. So M1 and A1. Okay. Usually, like I just say, the accuracy mark is lost if you had not gotten the M mark before. So if your method was wrong, or if your method was unorthodox, or something that is not possible in maths, then even if you get the answer correct in a lucky way, you will not get the marks for either of these. So it's very important that you learn the methods from the mark scheme, and you understand how the examiner expects you to write the answers or write the steps in order to achieve the full marks. Then the next one is B, which is going to be the most common one that you see in your paper. It's basically independent of method marks. These are the methods, or these are the questions which don't require you to show any workout, or it doesn't mandatorily require you to write how you got to an answer. So for example, let's say they had written 5x equals to 20. Just this concept, okay? Right after this, if you just write x equals to 4, they don't really care how you got this answer, because they think that this is so obvious and this is so preliminary, or let's say this is so elementary level, that you don't necessarily have to show the workout for this, or you don't have to show any method for this. So in this answer, they're only going to write B1, as in one independent mark given as long as you write the answer. That's it. No method required, no calculations required. You'll just get the mark directly. I'm sorry, I'm a bit sick. That's why I have to cough every now and then. I'm really sorry. The next mark is given Wait, let me just skip this for a second. The FT is basically known as follow through. I don't know if it's written anywhere. That's okay. It's not written here. I think no, it's not written here. So the follow through is basically this is also known as a student's best friend, because even if you make an error in part A, but then let's say a question has part A, part B, part C. The first part asks you to find the value of K. Find K. And you got K to be 20, whereas the actual answer was K has to be 10. Okay. So in part B and part C, if you use this method and sorry, if you use this value and you continue with your maths, you're gonna get the marks for this and this as well. Because they are just going to assume that if you had gotten the correct answer, then these answer would also have been correct. So since you're getting a wrong answer, but you're using all the methods correctly and you're getting the next answers, you will also get those marks. That's basically what follow through means. Follow through is the same thing as error carried forward. That's basically that the value that you had gotten in the first part, even if that is wrong, you had used that method correctly for the rest of the math. They're going to give you the mark for those rest of the maths as well. The only marks you're going to be losing is the final answer's mark. Does that make sense? So follow through helps you to get all the method marks, and you only lose the marks for the final answer because the answer is wrong. Does that make sense? Can I see your rounds of thumbs ups if that makes sense?
Yes, makes sense.
Okay, thank you so much. So I feel these are things that the students usually don't know. And this is something that the students must understand, that you should not be demotivated if you don't understand the mark scheme. And it's also very important that right after you solve the paper, you also go through the mark scheme to check your steps, to check your calculations. The next things I want to show are some of these abbreviations that you're also going to see very often. I'm not going to go through all of them because not every single one of them are very important. I'll only go to the most important ones. The first one is AEF or OE. This is where the students have the most amount of questions. It basically says any equivalent form or equivalent. Okay, so what does this mean? This basically means if the mark scheme says your answer is half, but then you wrote the answer as 0.5, is your answer correct or not? That's basically what it means. Okay, so you're going to see this very often, that the answer gives you like 9/12 OE. The mark scheme says this. So if you had gotten 3/4, or if you even wrote the answer as 0.75, you're going to get the marks for this as well and this as well. That's basically what OE means, or equivalent. So if your answer is equivalent to any other form of the same answer, you will get the marks for it. Okay. The second one is AG. AG basically refers to answer given on the question paper. So this basically means it's going to be the most important in questions where the value is given and they ask you to show how we got to that value. So in trigonometric ratios or in other questions, you might often see that the question tells you, given that x equals to 10 or given that sine theta equals to 5, find the answer of etc. etc. So in those questions, they will mark you more harshly based on the methods that you used. So since one of the answers are already given in the question, you get no extra marks for getting to that answer, but you have to be very careful on how you use that answer and how you use the value given in the question to get to the next answers. So that's basically what AG means. This is where it's marked very strictly on how you use the value given in the question to get to the other answers. The next one is seen or implied. This basically means that even if you miss a couple of steps, if you use a value, let's say in the formula for a square plus b square equals to c square, right? So it's advisable if the students writes the formula down, and then they start solving the values, like 5 square plus 4 square is equal to c square. Therefore, c is equals to root over something, right? It's very advisable if you use this and if you write all the methods or all the steps in order to get the full marks. However, let's say you are in a rush and you just write this directly without writing any of the previous steps. So the examiner at times, not always, like I'm repeating again, at times only, and not always, there are some questions for which they might give you seen or implied, which basically means even if you miss on a couple of steps, if you use the right method or the right understanding a right approach to solve the answer, they might give you the full marks. Okay, so this can also refer to, for example, they're working with a right angle triangle. So you are not really indicating anywhere that this is a 90-degree, but you are using the logic, and let's say this is 20 degrees, and they want you to find x. This was not given, only this part was given in the question. Okay, so if your method is directly to write 180 minus 20 minus 90 is equals to, let's say this is 70 degrees, right? So if this is a direct answer, by showing this entire step, you have not really mentioned anywhere that this is a right angle triangle, hence I'm using this 90-degree or anything. But since you write this entire step, they're going to give you the mark, implying that the student knows that this is 90 degrees, so they deserve the mark for this. Okay, so it's better usually that you write all the steps down and you write all the workouts in details. But if you write this, you might get the benefit of the doubt at times, and you get the full marks for this. Okay. And the last one that is very important, I feel like, is this one: correct answers only. This is where a lot of students lose the marks for their methods and for their previous steps. So we know that the most common mistake for students is the arithmetic ones, where they mess up plus or minus in the middle and they lose their marks for it. A lot of students usually hope that, oh, I had made a mistake in the second last step, and I had only given, let's say there was 5 minus minus 3, and instead of writing 5 plus 3, you wrote this to be 2. And then you hope that the examiner, they give you the marks for this because the entire workout was correct and you only made the mistake in the second last step. This is where the students lose their mark, because the examiner expects the correct answer only. And if you write something like this, you will not get the marks for this. Okay, let me just see if I can give you an example of this. So see, this is, all of these are OE, OE. So even if you got the answer in some other form, you will get the full marks for it. Okay. I can't find any CAO right now. But that's basically what the gist is. In some questions, they will very strictly expect you to write that exact answer. And if you write any other forms, you will not get the marks for it. Let me give you one more knowledge. So this is ISW. The ISW basically refers to ignore subsequent working. So this is also another friend of the students. So for example, if the question asks from you, find the value of x. Let's say you found the value of x to be 5, and then you kept on solving the maths. Okay, so you kept on solving other answers. For example, there were like this triangle where this x, there's x here, there is 2x, 3x here, there is 2x here, for example. Okay, so you found the x to be 5, and then you keep on solving the math. You write 2x is equals to 10 and 3x is equals to 14, let's say. Okay, so the question was just to find the value of x. Find x. This was your only question. This was your first step. This was your second step. This was your third step. ISW basically says the moment in time you get to the answer, everything else is insignificant. The examiner cannot mark you or judge you based on everything else that you wrote. The reason this helps the student is because, for example, in the third step, I had made a mistake. 2x was supposed to be 15, but I wrote 3x to be 14. I will not lose a mark for this. Since my answer was already given here, and the mark scheme says ISW, if I made a mistake in the third step, the examiner cannot mark me based on the second and third steps. So this is another place where we get the answer as long as we had we get the marks for this as long as we had given the right answer in the beginning. Does that make sense? So this is all the things I would like to cover from the mark scheme. If you read the mark scheme and if you read all through the details of all of these pages, you're going to get a better impression. But I would also like to start the paper since it's already been 30 minutes. So yeah, that's all from me so far from the mark scheme. Any questions? Can I see a few thumbs up, say if everything so far made any sense? Would you like me to repeat anything? Okay, thank you so much. So let's not repeat anything for now, and let's get to the paper directly. This was the paper we were doing, I believe. Yeah. Okay. So the first question is where we're supposed to use a tracing paper, and I'm going to show you one other way to do it without using a tracing paper. So the first question says that, okay, again, a very important reminder that calculators must not be used in this paper. If any student is seen with a calculator, their papers might get cancelled. Okay, so be very careful that you don't even have the calculator in your bag or you don't carry it to the exam center. Okay, so the first question says that shade one more small square so that the diagram has one line of symmetry. So a line of symmetry question usually has multiple answers, or it can have multiple answers, or I'm not saying it will always have it. It can have multiple answers at times. So check the mark scheme to see if your answer is one of them. The first thing I can see here is line of symmetry basically works like these, or these, or these, or this, one of these ways. Okay, and whenever, let's say, if this is the method I'm choosing, if this is the line that I'm choosing for my line of symmetry, my boxes on either side would be reflections of each other. So this box should have had the reflection here. I don't see that, right? So this can't be my answer. The way to solve this is to see the most common ones. So I can very easily see from this and this one that these are reflections of each other across this line, right? So the next thing I have to do is I first check that if this is a reflection of this, it is. So this is perfect. Okay. The next thing I have to see is whether there's any other boxes that I have to fill up. I can see that this box is on the right side, which means there should have been a reflection on the left side as well. And it's going to be this. So this is my answer. Any questions with this? Can I see thumbs up if you agree with me? Okay. There's another uncommon answer that a lot of students might not see. And that answer would be, okay, you don't understand. Let me just repeat. So a line of symmetry is basically if you folded this graph in half in one of the axes, and these are all the axes, you should get an answer. Okay, so if you fold this and if you start to see the reflections, so let's try reflections across this plane. The reflection would have been like this for this box. It would have been for this box, and for this for this box. That's basically how symmetry works, or this is how the reflections work. I can very easily see that this does not make it symmetric because my box is not here. Okay, or I don't even have a box here. So this can't be my symmetry. The second one I want to try is perhaps this. Again, I should be expecting a line here. I should be expecting a line here. I should be expecting a line here. I don't see any of this. So this can't be my symmetry either. Let's try this one. Sorry. When I try this one, I can see that there's a symmetry from this and this. It's basically a reflection across this line, right? So I can tell that this has to be an answer, and this could be my line of symmetry. But the question didn't really ask me for my line of symmetry. The question asked me to shade one more box so that it has one line of symmetry. Okay, so I can see that this box and this box, they have been accounted for. So the only box remaining is this one, and I have to reflect this one across this line. The way to do that is just to draw a box here so that these are reflections across each other. Okay. The 12th box, are you referring to 12 from like 1, 2, 3, 4, or like 1, 2, 3,
Yeah,
4? The
yeah, the
first one?
bottom. Yeah, no, yeah, the first
So
one.
this is 8. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12. Are you referring to this
Yes,
box?
yes, that one.
Um. Okay. So if I were to draw this as the symmetry, this would be a reflection of this box. Do you see it?
Yes,
So since I don't have anything here, I can't shade this. Does that make sense?
yes, sir.
Okay. However, the way that you would be right is on my other axis, which is going to be this one.
Okay, sir.
So if I use this ball, if I use this line of symmetry, I can see that this part of the line would have been reflected to give me this part of the box, right? This is the more uncommon answer that a lot of students don't think about, but this is also a correct answer. And this part of the box would have given me this part, which means I should now try to find this one. How do I find it? I'm just going to calculate from here and see that this comes out to be here, right? Any questions with this? So in that case, the 12th box would have indeed been the correct answer as long as I provide this as my reflection. Does that make sense?
Yes. Thank you,
Okay,
sir.
thank you so much. I believe we can go to the next part. So the next part of the question says that, where is it? Yeah. So shade one more small box so that the diagram has a rotational symmetry of order 2. Now, the way I want you to do this is you take a tracing paper. Unfortunately, there is no way I can show you this question through a tracing paper. But if you go to YouTube and you search how to solve symmetry, just search this, okay? Symmetry or this rotational, okay? Rotation using tracing paper. So watch a couple of short videos on YouTube with this, and I believe you will know how to physically use the tracing paper to get to the answers. Okay. So this question says that symmetry of order 2. So each order has one entire rotation. Okay. So basically a 90-degree rotation. So if you use a tracing paper, you're going to see that when I shift this entire box, think of this like a Rubik's Cube and think of when you're shifting this one whole time. Okay. So this box, this top line becomes this line now, right? So my shaded box here would have been this shaded box here. Similarly, this line would have been converted to this top line now. So the first two would have become this for one order of rotation. Are you all with me so far? Okay, lovely. So the second order of rotation, since the question told me that I have to use order 2, that means I have to do this once again. Okay. So now I'll be using this one. I'll be using this part and rotate it once again. So let's see how to do that. So this time, this line would have to become this new line. Let's use another color. It would become this line. And secondly, this line that already exists is going to become this line. Does that make sense? Okay, wonderful. So with that being said, sorry, give me just a second. Okay, so with that being said, since I already have this, my second one should be, so this thing now comes out to be here and the second one here, right? Let me just draw a new box. So these two would rotate and come to be in these spots. Do you see it? Any issues with that?
No.
Do you have any issues?
No,
No.
sir.
Okay,
No,
perfect. So since this box first comes to be here and then it comes to be here and here, that means the one more shaded square they were referring to basically just has to be this one shaded. Okay, since I would have to shade the first two, this is already shaded, so the missing one would be the second one. And I can also verify this a second time by now rotating this twice as well as this twice. So if I rotate, and I hope you stay with me, so if I rotate this one time, it's going to get, sorry, not here, is going to be here. Sorry, yeah, it's going to be here and here, right? Do you see it? Any issues with this? So when you try to think of all the ways that this would have been rotated, you can clearly see that this was the only missing one that we had to shade, and the ancestors just shade one more small square to get the answer. So the answer would be this box. Cool. It's way easier if you do this with a tracing paper and without having to draw so many diagrams. So the moment in time you use your tracing paper once, you're gonna get the hang of it. Okay. So watch a couple of YouTube videos, just search this and you'll see how easy this is. these are regarded as some of the chapters that you should never lose a mark in. Okay, it's very easy. Trust me on this, and practice the papers, and you're gonna get the hang of this. Okay. So the second part is from, I think this chapter is called scale and mapping. Okay, scale and mapping. So this one says that the scale shows the positions of two villages, P and Q. The scale is 1 centimeter, represents 0.5 kilometers. 1 centimeter represents 0.5 kilometers. Okay, so this is again something that you'd have to use or see physically. The scale is 1 centimeter, represents 0.5 kilometers. So since I'm not doing this on a physical paper, I can't use a physical scale to show you that this is drawn to scale, but I'll just show you how to do this on the actual paper. Okay, so you're gonna have a scale like this. What I want you to do is take the 0 mark to P, and then you calculate what you get for Q. Okay, so you take the 0 mark to P and you calculate what you get for Q. The answer here for me, sorry, let me just fix that once again. It was something like, I'll just use this. Okay, so I can see that my answer is from 0 till 8.5. 0 to 8.5 centimeters, right? And the question say that 1 centimeter represents 0.5 kilometers. That means that this 1 centimeter is 0.5 kilometers. This one is also 0.5, and this 8.5 is basically 0.5 into 8.5, which is 4.25 kilometers. Okay, are we good so far? So if you print this paper out, or the actual exam paper that you're going to have, it's going to give you the diagrams that are drawn to scale. Yes. Do you have any questions? No worries, no worries. It's absolutely fine. So your actual diagrams are going to be drawn to scale, which means you simply just take out a ruler and you see the length of this, and then you see the scale that has been given. So in this one, it says 1 centimeter equals 0.5 kilometers. So 1 cm equals to 0.5 kilometers. Let's say I got 9 centimeters. Okay, in the actual diagram, I got 9 centimeters. That would mean if this gets multiplied with 9, this also gets multiplied with 9. Okay, so 9 into 0.5, that is 4.5 kilometers. Let's just give that as the answer. Okay, the second part says measure the bearing of village Q from village P. Okay, the wording here is very important. So they say that I have to measure from village P. Okay, so from village P, I'm going to draw something like this, and then I have to see what my bearing is. So the way we do this is I can already see that this entire thing is supposed to be 90 degrees, right? If this entire thing is supposed to be 90 degrees, then wait just a second. Yeah, if this is 90 degrees, all I have to do is just see the angle of this, right? Does that make sense? The way to do that is, again, I can't show this since I'm not on a physical paper, but I'll just explain to you how to solve this one. So you take a protractor that I believe you should have. Sorry. So you place it like this, where this is going to be like this, and it should have all the angles given here. So I know already that from here to here should be 90 degrees, right? I have to see this extra part, which is going to come as 20 degrees if you draw this accurately. Okay, so you have to hold your protractor in a way where when you draw this, your answer here will directly show you 110 degrees. That's what the answer is going to give you. Okay, and I hope you know how to use the protractor. Again, I'm telling you from a very honest point of view that YouTube is a better friend to you for your IGCSE and A levels than any tutor or any school can possibly be. So if you go to YouTube, you're going to find an unlimited amount of resources, an unlimited amount of instructions or people trying to help you out. And all you have to do is just find the one tutor who is most comfortable with you, and or as in you understand their methods the best and you find them the most helpful. So if you don't know how to use a protractor, just search it on YouTube. If you don't know how to use a compass, search it on YouTube. You're going to find everything. Okay. So the answer for this should be 110 degrees. Once again, I know this is 90 degrees. And if I use a protractor, I'm going to say that this part is 20 degrees, which means the bearing should be 110 degrees. Okay. If the question asks from you, what is the direction, then you also have to use the concepts of north, south, east, and west. Okay. So this is north, south, this is east, this is west, right? Anything here would be northeast. Anything here would be northwest. Anything here would be southwest. Anything here would be southeast. Okay. If the question asks from you to find the bearing from the north line, then you'd have to go all the way. Sorry, you'd have to go all the way like this. I hope you know these. Can we move on to the next question? Do you understand how this came and this came out to be? Okay, thank you so much.
Yes,
Okay.
sir.
The third question is for angles, right? You have to understand the chapter of properties of angles for this. There are a lot of complicated things that the chapter covers. I'm going to show you the method that I used to personally use, and I found this to be very helpful. Okay, so the question formats are always going to be very similar. They're going to have two parallel lines, and then one line in between, right? I believe you've seen this in other papers as well, in our textbooks as well, that there's always going to be two parallel lines and one line crossing through those parallel lines, right? And then came all the rules of angles on opposite sides, exterior angles, alternate angles, etc., etc. You can obviously find the tutorials on YouTube. Like I said, you can find the descriptions on your textbooks, on any resources provided by your tutors or your school teachers. And they're always very helpful. They're very self-explanatory and they're very simple, and you have to understand all of them. The method that I'm going to teach you is very unorthodox, but I promise you it's always going to give you the correct answer. Okay? So whenever you have a parallel line and a line in between them, try to find Z's. Try to draw Z. Okay? Basically the letter Z, as in my name, Zawad, this Z, right? So how do we draw this? The letter Z comes out from two parallel lines and one line in between, right? That's basically how a Z is written. So we have to do exactly that, okay? Let's try to find our Z's here. I can see one line here. It goes here and this. Any questions? That's my first Z. The second Z is from here, sorry, the other way around. The second Z is from here, and here. Any questions with that? Okay.
No, sir.
So let's now see the function of this Z, okay? This Z basically says this angle and this angle, they're going to be the same thing. Okay? Can we remember that? This angle and this angle are always going to be equal. And the opposite angles, basically, if I were to extend that, this opposite angle will also be equal. This angle, this angle, this angle, and the opposite angle to that would also be equal. That is all you have to remember. Okay, let's see how to use this. So like I just said, we form a Z here. So this angle and this angle should be equal, right? Do we all see this? Okay,
Yes,
so this is 65
sir.
degrees. Okay, so the second thing I promised was that if this is one angle, this will be the exact same angle as well, right? So if this is 65, this should be 65 degrees. And if this is Z and this is 65 degrees, then the opposite angle to that, which is Y in this case, will also be 65 degrees. Do we all see this? I use absolutely no fancy terms for this, no fancy formulas for this. I use a very simple letter, Z. This letter that we've been learning since playgroup, I've just used that, okay? So Y is equal to 65 degrees. If you open the mark scheme, you're going to see that for this value, the mark was B1. Does any of you remember what B stood for in the mark scheme? The explanation I provided before the class, do you remember what the B stood for? It was independent. B stood for independent marks, right? The independent marks were where the method is not important as long as your answer is correct. This is B1, right? Okay, so let's do the second part now. So for the other one, which is basically this 45, let's see how we can use that. So we all understood how we came to this 65, right? I hope so. So the second one is going to have this. So I know that I have to use this somehow, which means my Z is now going to look something like this, this, and then this. Let's use the highlighter for this. So this line, and then this line, and then this line. That's basically my new Z now, right? I reverse Z. Again, I promised you that this angle and this angle, the inner Z's, right? If my Z is like this now, then this line and this line will always be equal. And secondly, the alternate angles like this line and this line are going to be equal, right? These angles will be equal. Does anyone have any question with this? Okay, wonderful. So with that being said, so I have formed my new Z. Let me just clear all of the other lines so that we are not confused. Let's just write y equals 65 here. So we know. Okay. So my new Z was here and here, which means if this and these are opposite angles, then this has to be 45. And as per the rule of Z, this will also be 45 degrees. Are you all with me? Okay, so the question really asks from me to find the value of x, right? And x is here. Now, the most important rule for these questions usually is that angles on a straight line equals to 180 degrees. As in, let's say these are all the sides. This angle, and this angle, all of these will always add up to 180. The rule for this is angles on a straight line add to 180 degrees. Perfect. So this entire thing should give me 180. I can already see that this is 45, this is 65, and this is the only unknown variable. So what we write is x plus 45 degrees plus 65 degrees is equals to 180 degrees. Hence, x is equals to 180 minus 65 minus 45. And if you try to solve this, I think you should be getting 170 degrees, if I'm not wrong. Any questions? Now let me explain to you how the mark scheme expects you to write this. So there is M1 for this. Does anyone remember what M1 stands for? Anyone?
Method mark.
Method mark, perfect. So this M refers to method, and then this one is either going to have A1 or B1. Okay? So A1 is for accuracy, as in you get the answer correctly, and B1 is for independent. So even if you write 70, you will get this mark, but you will not get the method mark. Does that make sense? So the method mark is just for writing this line. So if you write this line, even if you get the answer of x wrong, let's say instead of writing 70, you calculated x to be 60, and you wrote 60 here, you wrote 60 here, you will get the marks for this, you will not get the marks for this. Cool?
Yes, sir.
Okay, so I hope
Yes,
this
sir.
explanation has been helpful. Let's move on to the next question. Okay, would anyone like me to repeat anything here? I think the Z method is a very new concept. I don't think you've heard of this anywhere else. It's basically something I used to work with when I used to solve the papers, because I used to find it very hard to remember all the names and all the rules. So this is something that I found, and I have never been failed with this method. And I hope it helps you as well, in case you feel like the formulas are too overwhelming. If you're good to go with the formulas already existing in the textbook, please use those. Okay. all the tutors, all the teachers, and all the examiners are always going to prefer you using the conventional methods over any experimental methods. Okay, so if you're comfortable using those, be my guest. But if you feel like those are overwhelming and you would like to use a shortcut, you can use this. Okay, so moving on. Samira picks one of these cards at random and replaces it. So what does replace mean? Replace basically means, for example, if I have a box and I have 3 balls here, and I'm going to pick one of these balls out. So now I have 2 balls inside and 1 ball outside. Okay. So if the question says that I take 1 ball out and I replace it, this basically means I keep it back, or I take something from outside and I keep it in place of it. So at the end of this, I'm going to go back to 3 balls. Okay. So either I get something out from another place, or the ball that I had just taken out, I keep it back. That's basically what replace means. The other word is without replacement. Without replacement. In that case, what happens is I take this ball, I bring it outside, and I keep it outside. So the next time I take a ball from the box again, I no longer have 3 balls available. I have 2 balls available here. So my calculation changes entirely. And let's say I take another ball out and I keep it outside. Sorry. Let's say I take another ball out. Let's just erase this. Let's say I take another ball out without replacing it. That means the third time that I'm going to be taking something out of the box, I have just 1 ball available. Okay. That's how the calculation changes. However, like this question says, that is with replacement. That means if I have 3 balls here, I take 1 ball out and I replace it. So the next time I take a ball out, I'm going to be back to 3 balls. And then let's say I do it a 3rd time or a 4th time or a 5th time, it's always going to be 3 available options because I'm not changing the experiment. I'm just taking a ball out and I'm keeping it back. So when I go back to doing the experiment all over again, my scenario is exactly the same thing. So the calculation and the formulas are going to stay consistent. Does that make sense? Are you all with me? Anyone
Yes,
would like
sir.
me to explain the replacement concept again?
No, sir.
Okay, wonderful. Thank you so much. So find the probability that she picks an odd number. So I basically have 7 cards here in front of me. I have to see how many of them are odd and what are the odds, pun intended, what are the chances or odds of me getting an odd number, right? So I have 1 here, I have 3 here, 5 here, 7 here. That is basically 4 options out of 7 options, right? So probability formula is favorable outcomes divided by total outcomes. In this case, the scenario for me for being favorable is that I pick an odd number. So that is the 4 scenarios of getting 1, 3, 5, and 7. That's basically my favorable outcomes. And the total outcomes is the available number of options, which is 7. So the answer is 4/7. In the mark scheme, this would be B1. They don't necessarily expect you to write anything. If you just write the answer, you'll still get the marks for it because it's that easy in their eyes. Okay. Samira repeats this 35 times. Calculate the number of times Samira is expected to pick an odd number. So I'm going back to my previous explanation that if I replace something, I'm basically making sure that my method is not changing. That means the same workout every single time. That means this workout 35 times. Does that make sense? So 35 into 4/7. And since I'm not allowed to use the calculator, I'm supposed to somehow factorize this or cut out the factorizations. So this goes once, this goes 5 times because 7 5s are 35, and then 5 into 4, that is 20. Any questions? Okay, lovely. So I hope you can move on to the next part. This question is from transformational geometry. Transformational geometry. Okay, let's cover this one by one. So the first thing says, translate the triangle by the vector 0, -2. So let's first understand how the vector works. This is for the x coordinate or the x shift, and this is for the y shifts. Okay? If x is positive, I go to the right side. If x is negative, I go to the left side. Since x is 0 here, I don't go either of these. I basically don't shift this at all towards the right or towards the left. On the other hand, if y is positive, I go up. If y is negative, I go down. This one says -2, which means every single coordinate is supposed to go 2 units down. Are we all good with this? Okay, wonderful. So this part, and this part all go 2 units down. So let's start with the top one. 1, 2. So this becomes the new coordinate for my translated triangle. Okay. So this one also goes 2 units down. So 1, 2. This becomes the new coordinate. 1, 2. This becomes a new coordinate. So my new triangle should look something like this, and I label this saying T prime. Okay, that means the first transformation. Now let's say I am required to transform this again. Let's say I bring it here now. I would label this saying T double prime. That means this has been transformed twice. Make sense? Okay, I don't necessarily need this. The first one just tells me to go down 2 units. So I've just gone down 2 units. And that's all I have to write. I don't even have to write anything. I just have to draw this. Okay. The second part says, describe fully the single transformation that maps triangle T onto triangle U. So there's 3 types that we have to know. The first one is, I think, reflection. By the way, these are types of transformations. Okay. The question has specified transformations. The question has specified that there has to be, it is a single transformation. So we have to only write in terms of transformations. So the first option is reflection. As in the first question that we had done of symmetries, reflection is like this. The second one is, I think, sorry, where is it? Yeah. The second one is, I think, enlargement. The third one is rotation. So let's cover this one by one. Let's say this is my triangle. The reflection should be something like this, where the size is the same, the distance are the same, though it's a bit inaccurate in this case. Yeah, I think this is better. Or a reflection like, let's say, even this, or a reflection like, sorry, let me just see how it's reflected. Something like this. No. Yeah. Okay. These are the reflections. So I can see in this case that this can't be a reflection. It's neither of these. It's not this. It's not this. It's not this either. If I reflected this across this or something, my graph would have been something like this. Sorry, my graph would have been something like this. But that is not my new graph, right? So this can't be a reflection. The second one is enlargement. Enlargement, as the name just suggests, your shape either increases in size or it decreases in size. So my triangle from this should have become something like this, let's say. Or it should have become something like the smaller version, something like, let's say, this. I can see that this unit is 2 units. There's also 2 units. The base is 1 unit. The base also is 1 unit here. And the hypotenuse is almost 2 units. And there's also 2 units. So obviously, this is also not enlargement, right? Which leaves only rotation in our options. It has to be rotation. The other way to test for rotation is by simply saying that if this is my triangle, rotation, let me just see if I can rotate this somehow. I don't think I can. So a rotation of counterclockwise would make this to be something like this, a rotation of 90 degrees in the clockwise direction would have turned this into this, and a rotation of 180 degrees would have turned this into, I believe, something like this. Okay, so from the first option, we can see that this is exactly the same shape that this has gone through, which means I rotated my triangle 90 degrees towards the anti-clockwise or counterclockwise. Sorry, either anti-clockwise or counterclockwise direction. Does that make sense? Are you all with me? So the first thing we write here is rotation. And I think this question should be at least 2 to 3 marks. It's 3 marks, right? So I have 3 things to write here. The first thing is rotation. So my triangle has been rotated. Then I write in what direction. There are 3 types of directions on both sides. One is 90 degrees. One is 180 degrees. One is 270 degrees. There is clockwise and there is anti-clockwise. Okay. There is a table that I would like you to know. It will be very hard for me to show it here. Okay, let me just give you a link for a table that I really want you to keep saved for your maths. It's not necessary in this math specifically, but there are other questions where that table will be very handy, and it's very important that you know that. Okay. Let me just find the similar tables for you. Yeah, I think I got the right table. I'm giving you a link. Please download the image here, okay? It's a table that shows how the initial image changes into a new image after the certain transformations across either 90 degree across either clockwise or anti-clockwise and the angles. Okay, so it's very important that you understand those, and if you need any help afterwards, please let me know. So this one is the rotation, and as we see here, it's 90 degrees in the anti-clockwise direction, right? So sorry, let me just give me just a second. So the answer here is going to be rotation of 90 degrees in the anti-clockwise direction. Are we all okay with this? Can I see approval from you guys if this is the answer so far? Okay, so we have gotten 2/3 of the answer.
Yes,
We have
sir.
gotten 2 parts. We have just 1 part remaining, which is the center of rotation, as in across which point this gets rotated. Okay, so there's a calculation way of doing this, which is, I think, something that you would find in a few textbooks. And there's another way of doing this through diagrams. Okay, I'm going to show the diagram method, because the calculation method, a lot of students often make mistakes in that. So I want to show you a method that is approachable for most of the students. Okay, so for that I have to clear out everything here. So the method I want you to follow, or the method that I would recommend, is you join the new image and the old images corresponding points. So I can visually see that this is the top point for both the triangles. So I join these. Then I join, okay, before I start doing something else. So what you have to do is, you all have a compass, right? Compass in which you can use a pencil and you can draw circles like this and this. We can do this. So take your pencil, take your compass, keep the compass's needle here, and then I can visually see that this is the midpoint, right? If this is the midpoint, take your pencil somewhere along this line, anywhere. Okay, so you take your pencil, you cross the midpoint, and then you see the points that you draw, something like this and something like, let's say, this. That's basically what you're going to get when you draw with a pencil, right? Are you all with me?
Yes, sir.
Okay, and then what you do is you take the needle on this side, you keep the pencil on this side, and you do the same thing on the other end as well. Okay, so let me just draw this a bit more accurately. If you put the needle here, and the pencil somewhere here, and you draw a line like a circle, like some axes, you're gonna get points, I think, along this point, I think, on this end, and then you're gonna do something along this end. Okay, And then on the other end, if you keep your needle here and the pencil around here, and then you draw lines, you might get it along this point. And then it's very hard to draw this visually. Wait, just a second. Let me just think how I can do this. So if I keep the needle here and the pencil here, I get this, and I get somewhere around this. And then if you keep the needle on this end needle, and the pencil here, you would get something like, I guess, in this direction as well, and then this direction. Okay. So the idea is basically to draw a perpendicular line, basically a line that goes like from the midpoint, the line goes something like this. Okay. Are we all cool with this?
Yes, sir.
Okay. Let me just draw this more accurately. So it goes something like this, I think. Okay. Secondly, you do the same thing for the other lines as well. So let me just erase this line. Always do this with pencils. So I'll join this line with this line. I'm going to draw a line here. And then from the midpoint of this line, so the midpoint of the line should be somewhere around here. And I'll draw a line which is almost perpendicular to this. Okay, wait, let me just fix this. So the midpoint should be here. And the perpendicular line should be somewhere along this line. Do you see it? This is the 90-degree line? Yes? Perfect. The third line that I'm going to draw is this point and this point. And when I draw a line across this, let's just see. So I draw it here. Let me erase this line, these points. Oh no, my line is also gone. So the midpoint of this line is going to be somewhere around here, I think. And then if you draw a line which is perpendicular, you're going to see that all three of these lines intersect at a given point, right? Do you see it? It's 2, 2, right? So the center of rotation, so this is 180. Sorry, not 180, it was 90 degrees anti-clockwise. And the center of rotation is 2, 2. Does anyone have any questions with this? The method is 1, find the midpoint. Find midpoint. 2, draw perpendicular line. 3, join all 3 perpendicular lines. And once again, for anyone who did not understand the needle and pencil method that I was referring to, all you have to search on YouTube is how to draw perpendicular bisector. The second thing you can search is find center of rotation outside origin. So these are the concepts that I've used here. Okay. Just take 10 seconds here. If anyone has any question, please ask. We have enough time. I promise you we're going to finish the paper. If you have any questions or you would like me to repeat something, please let me know. These are one of the questions. This is one of the questions that a lot of students struggle in because they have genuinely just never understood how to approach the center of rotation math. So you either use my method, like the one that I just said or showed you. And if you want further explanations or more visual explanations, you can see these 2 videos, okay? Perpendicular bisector and finding the center of rotation outside the origin, okay? So that's the answer for this one. Can we move on? Thumbs ups? Lovely. Thank you so much. Please repeat the question for center of rotation. Okay. So the method I used was, let me just erase these. The methods I used were, I have this initial triangle and I have this new triangle, right? What I'm going to do is connect the dots of all the corresponding points, which means I know that this is the top of the triangle. This is also the top of the triangle. So this was actually the image that was transformed, right? So I'm going to join these two lines. And I'm going to find the perpendicular bisector of that line. Perpendicular bisector basically means you find the midpoint of a line and you draw a line which basically gives you 90 degrees here. Does that make sense? So in this case, the 90-degree line, if I see it very accurately, I think it's gonna be somewhere along this line, I think, okay? If this is 90 degrees, then that is all I have to see. The second thing I do is do the exact same thing for all the other lines. So let me just erase this line so that it helps us. And I'm just gonna keep that line, okay? So the second one is, this is the base, this is the corresponding base, and I'm going to join these two lines. And again, I'm going to draw a perpendicular bisector. How do we draw a perpendicular bisector? We find the midpoint, which is this in this case, and then we draw a line which will give me a 90 degrees here. 90 degrees, right? So it's going to be, I think, somewhere along this line. And usually by the second point, you should already see the point, which is this. But I'm also going to show you the third point, just in case you understand, okay? So this is the third one. This is the third one. I'm also going to join these two lines. And then what I do is, I find the midpoint of that line. It's going to be somewhere around, I think, 2.5. So this is going to be somewhere around here, I think, okay, if I'm not wrong. So again, I have to draw a line, which is going to give me a 90 degrees here. So the line goes something like this, I think, if I'm not wrong. Does that make sense? So the point here, where all three lines should intersect, is basically the center of rotation. And I can see that this should be the answer as well. Okay, the center of rotation is basically the point across which our initial graph or initial shape is rotating. Does that make sense? We are going to choose one point from which our point acts from, or the rotation acts from. So what I have been describing you was the method for finding this. The method is, one, we draw a perpendicular line connecting, connecting two corresponding points. Sorry, I don't have too much space here. Draw a perpendicular line So corresponding points basically means that whatever the highest point was on the initial graph, I'm going to be choosing the highest point on the newer graph. This is basically transformed into this shape, right? So similarly, the second point that I choose is going to be like this edge, which is the same thing as this edge of the triangle, right? The third one is the 90-degree one, which is the corner, and in this diagram is this corner, right? So these are my three corresponding points. The first thing we have to do is drawing the lines for the drawing lines for connecting these corresponding points. So I'm going to draw a line like this. I'm going to draw a line like this to connect these. And thirdly, I'm going to draw this to connect this. Okay. The next thing I do is, for these three new lines that I've drawn, forget the old shape, forget everything else. Just focus on the three new lines I've drawn. Okay. For these three lines, we have to find the perpendicular bisector. Perpendicular bisector. These are basically lines which cuts the line at the midpoint at 90 degrees. So if this is my line, I cut the line through a midpoint at 90 degrees, something like this. Okay, so let's try to do it accurately. Are you understanding the things that I'm saying so far? Just connecting the 3 points. Okay, so we understand the first part, right? The one struggling. Wait, I don't get what you're trying to say with the emoji. Do you understand the connecting part only, the first part of the question? All I'm doing is just connecting the corresponding points. Okay, this point with the highest point. Okay, lovely. So, okay, lovely. So the next thing I'm going to do is just find the midpoint of these lines. Okay, so always remember, find the midpoints. So this is one midpoint. This is one midpoint, and I think somewhere around this is the midpoint, right? Do I understand till this point that I drew 3 lines and I simply measured the midpoints? You can just use a scale to find the midpoint from here to here, and wherever the midpoint is, you just draw a line here. Cool? Okay, wonderful. The third thing you will do is from that midpoint, draw a straight line. So from this midpoint, I will draw a straight line. Wait. From this midpoint, I'll draw a straight line which gives me a 90 degrees here. Does that work? Are you with me? All I did was find the midpoint and draw a straight line which gives me a 90 degrees, right? Okay, the ones who are struggling, could you please confirm if you understand this point? Okay, thank you so much. Again, for this second line, I'm going to do the exact same thing. I found the midpoint already. I just have to draw a straight line, which gives me a 90 degrees here. Okay, so I'm going to draw a straight line. Okay, wait, let me just draw this properly. So, like a line like this, my aim is to find the 90 degrees here. So I'm going to draw a straight line once again. Something like this, right? Which gives me a 90 degrees line here. 90 degrees. Use your scale, make sure the lines are straight, and you should get the answer. Okay? So this was the initial line. This is the perpendicular bisector. This was my initial line. This is the perpendicular bisector. Are you with me? Perfect. So just from these two, I should already have the answer that this intersecting point, if I erase everything else, this intersecting point is 2, 2, right? This is the answer. Okay? This is the center of rotation. I would highly recommend that you see a couple of these videos, you watch a couple of these videos, and I promise you it's going to be way easier for you then. Okay? Just remember this, and I hope that it's going to be easier for you. Can we move on? Okay, thank you so much. Let's see. I hope that was easy enough to understand, or I hope that you eventually figured it out. So let's move to the next point. I feel like this is the easiest part of the paper. This is something that we've been learning since grade 5, grade 6. It's just basic algebra. There is no way we should mess this up, okay? So 8x is equals to 39 minus 7. So 8x is equals to 32. X is equals to 32 over 8 equals to 4. Simple as that, right? X equals to 4. 2, 5y minus 1 equals to 24. So there's two ways of doing this. One is to expand the bracket, or just take this 2 and divide this by 2, right? So let's just do either one of them. Let's do the easier one. So this becomes 5y minus 1 equals to 12. 5y is equals to 13, basically taking this to the right side. And then y is equals to 13 over 5. Any questions? So this answer in the mark scheme will have something written like 13 over 5 OE. This basically means you might write the answer in this form, or there are some students who would like to write this in decimal form, and they write 2.6 instead. This is also a correct answer. Regardless of which method you choose or which answer format you choose, is the same thing. That's basically what OE means. Cool. Can we move on? Okay, lovely. This is from arithmetic progression. Wallahi, you'll pass. Try your best. You still have time. When's your exam? Do you happen to know when your exam is? The exact date?
Mine is October, November.
October, November. And do you happen to know when the May, June exam is? November. Brother, you have like 6, 7 months. Like 5 months, I believe. You have enough time to prepare, okay? Don't worry about it. You've got this. I promise you've got this. Okay, so let's do this. Arithmetic progression is basically used in the formula of this, which we will be using for the future part. Wait, my pen has run out of charge. Give me just 2 minutes. I think you have 5 or 6 months, right? Okay, so in this question, I can see that this is an arithmetic progression because the terms, they decrease by 3 exactly, right? So 11 minus 3, that is 8. And then 8 minus 3, that is 5. 5 minus 3, that is 2, right? Do you see this? So these are all decreasing by exactly 3. The difference is exactly minus 3. So when they ask from you to find the next term of the sequence, you basically have to just take 2 minus 3, right? Are you all with me? So the answer would be minus 1, right? Just a plain simple minus 1. Perfect. The next one says find the nth term of the sequence. This is where you basically use this formula. So let's just write this here. Okay. So a plus n minus 1, where a is the first term, n is the nth term we're trying to find, and d is the common difference. Okay? So in this question, I can see that these are all decreasing with minus 3. That means my d is minus 3. Are we all cool with that? And a is supposed to be the first term, which means the first term is 11. So a is equals to 11. Do we get this as well? So the formula is nth term is equals to a plus n minus 1 into d. So that is 11 plus n minus 1, and d was minus 3. Any questions? Do you have any questions? We basically
sir.
just plugged in this value and this value from these, and we got this, right? Can we go back to 6b? Yeah, we can. Do we have any questions? Okay, no
No,
worries.
sir.
Yes,
So I got 2.2 for 6B.
2.2.
Yeah, I did get 2.
Did you get 5y equals 13 initially? Yes. Did you get this? Aaron,
Yeah,
did you have this?
no.
Okay, so I think you expand the bracket, right? So 5y minus 1 equals to 24. That is 10y minus 2 equals 24. I think you've made a mistake here, I believe, right? So with that being said, this 2 gets there. So 10y is equal to 26. Y is equals to 2.6. I think what you've done was take this your minus 2 as well, right?
Yeah, I did minus 2.
Yeah, so there was your mistake. It's completely
Okay.
fine. Don't worry about it. So 24, this is minus 2. Cool?
Yes,
Okay.
thank you.
So let's going back to this question. Now I have to expand this bracket, right? It's basically the same thing as writing this minus 3 in front. So this is what the equation becomes, right? So 11 minus 3n plus 3, which is the same as writing 14 minus 3n. Any issues with this? This is the formula you have to use, and you just plug in these values here, and you get the answer. Cool? Okay, wonderful. For HCF, I'm going to show you two methods, and you choose whatever method you want to use. Okay. So the first thing you can do is write 36 and 54 together, and then you prime factorize this. That's basically dividing with prime numbers. Okay. So I can see both of these are even numbers. So divide by 2, that is 18 and 27. I know that 18 can be divided by 2, but 27 can't. So I'm going to choose 3 instead. 3, 6, and 9. Then again, 6 can be divided by 2, but 9 can't. So I'm going to choose 3 all over again. This gives me 2 and 3. Are all of these prime numbers? Do you know this? All of these are prime numbers? Is there
Yes,
anyone
sir.
here who'd like me to explain what a prime number is? Okay, lovely. So the shortcut for this is, if the question asks from you to find the HCF, you simply multiply these values until the last step. Does that make sense? This is my last step, right? So for HCF, you choose all the values until the last step. That's what you do for HCF. For LCM, let's take another color. Let's take blue. For LCM, what you do is you choose all the values. That's the difference. Okay. So our HCF should be 2 into 3 into 3. That is basically 18. So our answer is 18. Now, let's say the question didn't ask from me, but let's say the question also asked from me to find the LCM. Okay. So in this case, as I said, you multiply all the values, right? So 2 into 3 into 3 into 2 into 3. That's for the LCM. The answer would have been 2 3s are 6, 6 3s are 18, 18 2s are 36, 36 3s are 108. So the answer is 108 for the LCM. Cool? Did you say anything? Okay. Yeah. So that's the method. This is the first method of doing this. Okay. For HCF, you only multiply till the last step. For LCM, you multiply everything, including the last step. Okay. Now I'm going to show you the second method. The second method is solving this separately. So this is 36, this is 54, 2, this is 18, 2, this is 9, this is 3, this is 3. For 54, 2, this is 27, 3, this is 9, 3, this is again 9. Now what you do is we write 36 as a factor, as a product of all its prime numbers. So 36 is equals to 2 into 2 into 3 into 3, while 54 is equals to 2 into 3 into 3 into 3, right? For HCF, what you do is you find pairs of all commons, okay? So for one pair, I can form this. 2 and 2 is one pair, right? For this 2, do I have any pairs here? I don't, right? So I can't use this 2. This 2 has to be out. For this 3, I can form this pair. For this 3, I can form this pair. This 2 has no pairs. This 3 has no pairs, right? Now you just multiply the pair. So that is 2 into 3 into 3. That's basically this 2 is here, this 3 is here, and this 3 is here. That's basically how I get 18 as well. That's for the HCF. Okay? For the LCM, you'd also have to multiply this and this. So this into 2 into 3. Any questions? Seeing none, I'm going to move on. Okay? Are we all cool with this? Are you absolutely sure? Okay. So let's move on. Very important question, very important chapter. It's from vectors, okay? It's very understand that you understand this chapter. So vectors, in vectors, I have two types of vectors that we have to understand. One is what AB is and what is OA. Okay? So before I even start the question, I'm just going to show you two different things. For example, if this is a graph, this is the origin. Let's say this is point A, and let's say this is point B. Okay? So when I'm going from origin to A, this is what I mean by OA. Okay? Are we all cool with this? The distance from O till A is represented by OA. Similarly, when I say AB, I think you can guess This basically means going from A till B, right? That's the distance of A till B. I really appreciate that. I hope you keep on learning. Please tell me if you struggle anywhere, okay? So from A till B, that's basically this vector, okay? So now let's start the question. The question says that my coordinate for A is basically 3 and minus 1. So it's somewhere, if this is minus 3, sorry, it's 3 and minus 1. If this is 3, minus 1 is here. So this is where somewhere where my A is, okay? I don't have to draw any diagrams. I'm just showing this so you understand better, okay? So this, let's say, is 3 comma minus 1. AB is 2 and minus 4. That basically means I don't start from origin. Instead, I start from A, right? Because it says AB. So I start from A, I go to B, and the distance of travel is basically this, 2 minus 4. Now, if you can recall from a few questions above, I told you what this vector represents, right? It was, I think, in this, where was this? Yeah, remember this? If X is positive, I go right. If X is negative, I go left. If Y is positive, I go up. If Y is negative, I go down. So this basically refers to, no, I don't play PUBG Mobile. So this is basically, okay, my pen is out of charge once again. So give me just 2 minutes all over again. So when I say 2 comma minus 4, this is basically referring to 2 right and 4 down. Do you all see it? From my point A, I'm going to go 2 units right and I'm going to go 4 units down for my point B. Do you all see it? Does anyone have any questions when I say this? That this is 2 right and 4 down? No questions? Okay, wonderful. So that basically means that if my coordinates for A is 3 comma minus 1, for 2 units right, I'm supposed to go 2 units towards the right, right? So my 3 becomes 5 now. 3 plus 2, that is 5, right? Similarly, my minus 1 goes 4 units down. So from minus 1, I will now go 4 units down, right? I went 2 units right, and I'm now going to go 4 units down. So it basically becomes 3 plus 2, comma, minus 1, minus 4. Any questions? Yeah?
No, sir.
Okay, so this becomes AC, no, not AC actually. This becomes 5, comma, minus 5, right? Yeah? Are we all cool? Okay, so just a second. Sorry, this is for B. So the coordinates of B is 5 comma minus 5. That's basically what this information gives me. The thing is, the question doesn't really ask from me the coordinates of B. I'm just explaining B with reference to vectors and how to solve this, okay? So now I'm going to solve for the actual question, which is this, okay? So AC is equal to 2AB. This basically means my distance of A to C is equals to 2 times the distance from A to B. Are you cool with this? So this basically means whatever my distance from A to B is, multiply that with 2, and I should get the distance from A to C. So 2 times this thing, right? That is 2 minus 4, and this comes out to be 4 minus 8. Any questions for this? All thumbs ups, I believe. So if that is the case, then my distance from A to C is 4 minus 8. But keep in mind that they ask from you the coordinates, not the distance from A to C. So now I have to go back to this concept of what this actually means. This means 4 right and 8 down. From where? From A. Do we all know why it's from A? Because the distance that I've just found out was from A, right? So my distance from A to C is now 4 right and 8 down. And I have been given the coordinates of A. Can you give me the answer for C? Can you write in the chat box? What's the answer for C? 7 and 9. There's a problem with the 9. It's minus 9. Perfect. Do all of you get this? Wonderful. So this is one of the most important concepts that you have to understand from vectors, that what the distance means and what the coordinate means. The coordinates are basically from the origin, from 0, 0, right? Okay, wonderful. Yes, Aaron?
So from when you got the 4 minus 8, how did you get to the
4.
seven?
So the 4 minus 8 was
Mhm.
basically, remember our conclusion that this means my distance from A to C is 2 times distance from A to B. Do you recall this?
Yes.
From this, right?
Yeah.
They've already given us the distance from A to B. So that's 2 times 2 minus 4, right? That's basically 4 and minus 8. Do you see it?
Yeah.
So this means my distance from A to C is 2 times the distance of A to B. The distance of A to B is 2 into minus 4. So 2 times that is 4 and minus 8, right? So that is the distance from A to C. Do you see it?
I see. Okay. Yeah, I
So
see.
this plus the coordinates of A now, right?
Okay. Yes.
So I go from 0 till A, and then from there I go 4 units right and 8 units down. So basically, whatever my coordinates of A is, that is what I add 4 and subtract 8 with, right?
Yes, sir.
So A has been given as 3 and minus 1. So 3 plus 4 and minus 1 minus 8, right? That is how I get 7 and minus 9. Any questions?
No, sir.
Okay, thank you so much. Now, let's go to the next part. The next part says the length of AB is k root 5. I want to use a very simple formula for this. The derivation of the formula is basically the hypotenuse formula, but let me just show you. So basically, from this diagram, let's say if this is point A and this is point B, let's also get rid of these. So this is A, let's say this is B, and I have this, right? So in order to find this length, I have to use the concept of right angle triangles, which is basically joining this and this. This session ends at, I hope it ends at your time. Wait, what's your time now? It's 3:47, right? So it ends at 4:30. Okay. If you have other commitments, you can go to those classes or something, and I'm going to hopefully provide you with this recording. Cool. So this is the x coordinate or the change in x, and this is the change in y. And for finding this length, as per the hypotenuse formula, I'm going to have to add x square plus y square to get the length, right? The length square. So the formula that we have to use here is length of AB is equals to the square root of x square plus the y square. Are you all with me? Yeah?
Yes, sir.
Okay. So with that being said, the length of AB has been given as 2 and minus 4. So all I have to do is plug in these values. 2 square plus minus 4 square. This is where I got this from, in case you're wondering. So that's the length of AB. So this comes out to be root 20. Now, the problem with this is the question expects from me in this format, not in root 20, right? So I have to find a value of k which satisfies this. How do we do this? So when I have root 20, I have to find values which gives me something like something into something is 20, right? So something that comes to my mind is 2 into 10. But the problem with this is there is no way I can get to this format using this, right? I have to have a 5 inside. So the other pair that I can use is 4 into 5. We know that this can be written as, bring this 4 outside as 2 root 5, right? Does anyone have any problem understanding this? And since the question told me that the format is k root 5, I already have my root 5 here. That means my k has to be 2, not 2 root 5. Okay.
Yes, sir.
Okay. So the next thing, p. Did you raise your hand for anything, or is that saying that you're okay with this? Okay, lovely. So the next question says C is a point on AB such that AP and PB is 1:4. Let's understand what this means. This basically means if I have a line of A till B, I have to find something, as in this basically means there is 4 parts now. 1 plus 3 equals to 4 parts now, right? There's 4 parts to this line such that this is 1 part and this entire thing is 3 parts. That's basically what we mean by 1:3 ratio. Do you understand this? So this point has to be P, where this AP is 1 unit and this P to B is 3 units. Are you cool with this? With that being said, let's now try to find this. So AP is PB. Okay. So this entire thing is AB, right? This is AB. And our AB was 2, minus 4. Something like this. That means we are not taking this distance and dividing this into 4 parts, right? Into 4 parts. Are we all cool with this? So 1/4 of 2 minus 4. So that is basically 1/4 of 2, which is 0.5. And then 1/4 of minus 4, which is minus 1, right? That's basically the distance of A to P. Do you have any questions? Similarly, if you were to find P to B, that would have been 3 times of this distance, right? So 3 to 4 of 2 minus 4. This would have become, so this becomes, I think, 6/4, which is 1.25. And then this becomes 3/3/4 into 1, sorry, into minus 4. That just comes out to be, I think, minus 3, right? So if I were to find the length of PB, this would have been a vector. Does that make sense? So what I just found out was the length from A till P, the length of A till P, just this part, right? The question asks from me to find the position vector of P. This basically means the coordinate from the origin, okay? And if you recall from the very first concept, to find the origin, after I found AB, I have to now add the coordinates of A. You remember this? If I have this, and I have the coordinates of A, to find the coordinates of B, what I need to do is add the coordinates of A and then the position vector, right? So in this case, it's going to be P AP plus the coordinates of A, right? So that is 0.5 minus 1 plus the coordinates of A were 3 minus 1. Right? So this comes out to be 3.5 and minus 2. I hope you all get this. Do you have any questions? There's a lot of formulas that you might find in other YouTube channels, or you might find in paper solutions, or you might find in the mark scheme, or you might find in the textbooks. I'm trying to show you the methods that are going to help you even if you don't know any formula, and you can visualize this, okay? So I hope this has been helpful so far. Let's move on. Question number 10. The diagram shows the sector of a circle, center O. The length of the arc is, they're basically referring to arc length to be n pi, okay? So the formula for for the arc length is basically theta over 360 into 2 pi r. Do we all know this? 2 pi r is the formula for the circumference of a circle, and theta by 360 is basically referring to this part of the circle in comparison to the whole circle, okay? So this is the derivation of the formula. This is where it comes from. So there is that, equals to n, sorry, let me write this properly, equals to n pi as per the question. So theta is known to be 45 in this question. R is known to be 18 in this question. So that keeps only this n to be found. Let's see. So 2 18 is 36. 36, let me just write this, 45 over 360 into 36 pi, right? I can see this 36 and this 360 can easily be written as 1 over 10. And this 45 and this 10 can be written as 4.5, right? So this is 4.5 pi. I hope you all get the same answer as well. So n is 4.5. If you compare this and this, you get 4.5, right? Any questions? Let's move on. So write 0.00708 in standard form. Standard form is basically something like 3.02 into 10 to the power something, either 5 or 10 to the power minus 5. I don't understand. Okay. So what I did was just use this formula. Okay. Let's forget n. Do you understand till this part? Just this? Do you understand this? It was you, right? Okay, lovely. So with that being said, let's just cut some values out. I know 36 divided by 360 is basically the same thing as 1 over 10, right? So I'm going to cut this once. I'm going to cut this and write it 10. Cool? So what I have now is 45 over 10 pi, and 45 by 10, that is the same thing as writing 4.5 pi, right? The question told me the arc length is n pi. So n is a value and then a pi along with it. N is the coefficient of pi. I have also gotten a value like this, where I have a pi and I have a coefficient in front of it. That means my n has to be 4.5. Do you understand it now? Yes? Okay, thank you so much. So, like I was saying, a standard form question is something in which you have a decimal point, you have a number in front of it, you have decimals after it, and then you write it in terms of 10. Okay? That's basically what we mean by standard form. Okay? So from this number, I can just visually see that I have to have a decimal and I have to have a number in front of it and decimals to follow in after it, right? So this has to be something in terms of 7.08 and then something to go with it, right? I'm going to go get to that later on. Do you understand how I came to this? Would anyone like me to repeat this? Okay, lovely. So that means I have to now see how would I get this, right? So the transformation is basically, if I had a decimal place here, I'd have to go 1, 2, 3 times to my left, right? Whenever I'm going towards the left, it's always going to be in terms of negative numbers. So that is minus 3. Does that make sense? So if I had this, and for this one, what I would have to do is take this decimal point and go 3 times to the left. So 1, 2, 3. My decimal place would be here. I'd have a 0 here, a 0 here, and that's basically it. Right? Is everyone okay with this answer? Wonderful. Thank you so much for actively participating. I really appreciate it. So with that being said, the second part is now work out this and this. So this part, it usually doesn't matter. What we'd have to instantly focus on is this number, okay? We have to make sure that it's constant, it's the same number. So this one is 22 and 23, right? What we can either do is turn both of this into 22, or alternatively, what we can do is make both of these 23. Okay? So let's do this one. Let's give it 23. So this one is 22. I would have to make this 23, right? That means I would have to take this one place to the left so that I have a plus 1 here, right? Is everyone okay with this? Whenever I go one place left, I'm going to have a plus 1 here. Whenever I go one place to the right, I will have a minus 1 here, okay? So that's why, since I'm going one place to the left, I'm going to have a plus 1 here, and this comes out to be 0.38 into 10 to the power 23 now, right? Because I got a plus 1 here, plus the old version of this. So 3.8 into 10 to the power 23, exactly the way it was before. I didn't change anything here, right? So now that I have this as the same number, I can basically just do 0.38 plus 3.8 into 10 to the power 23. I can write this as one whole. Any questions with this? So this comes out to be 4.18 into 10 to the power 23. Okay? I hope you're all cool with this. Okay, thank you. So let's move on. This is from, I think, circular measure, unless there's some other name for this in the chapter. PQR lie on a circle. QR is a diameter. So this is the most important part of this chapter, in this question, that QR is a diameter. Find angle PRQ. Now, a lot of students just have never learned this, that which exact angle are they referring to. Whenever they're saying this, they refer to the middle angle, okay? Another way of saying this is just this. Find the angle of R. So where is R here? R is exactly here. Okay. So give geometrical reasons for your answer. Now, there are some circular measure theories or facts that you have to know. So you'll find it in your textbook. There's like 6 or 7 or like 8, I think 6 to 8 facts, or like, what are they called? They're formulas, theories that you have to understand and you have to memorize. So one of them, as far as I remember, whenever there is a point on the diameter of a triangle that was formed from whenever there's a point on the circle that was formed from a triangle in a diameter, that point will always be 90 degrees. Okay? This basically means, since this is a diameter, if I form any point here, here, or here, and I connect these with my diameter, oh my god, the pen is out of charge once again. So give me 2 minutes. Yeah. So if I connect this as a triangle, or if I use this point and I connect this as a triangle, then every single one of these points are going to be exactly 90 degrees. Okay. That means this P is also 90 degrees. Do you get this? Yes. So if my P is 90 degrees, if my Q is 74 degrees, my R has to be 180 minus, so let's write this. I hope I can write this. So 180 minus 74 minus our 90 that we just found out, right? That's basically the workout for R here. Any issues with this? So I believe if you equate that, you get something like, what do we get? 76 degrees? Sorry, 16 degrees. My bad. So what we get is 16 degrees here. So this is 16 degrees. And the reason for that is P, let's write this as well. P is on the circle forming a triangle with diameter. I think the diameter was Q and R, right? With diameter QR. Hence, P is 90 degrees. Sorry. Hence P is 90 degrees. Angles add up to 180 degrees on a triangle. So R is equals to 180 minus 90 minus 74. Are you all cool with this answer? Can you please check and you let me know if you have any questions with this? Can you remember the circle theorem? That's the word. My bad. I was saying theories and facts and whatnot. The chapter for this is circle theorem. Circle theorem. Okay? So I hope you recall all the concepts that you learned here, and these are going to be very important for the exams. There has to be a question from this chapter, is guaranteed. Okay? Moving on, 100 students solve a puzzle. The table shows information about the time taken for each student. Okay, so work out the estimate of the mean. The formula for mean is sum over total. So the way we find sum is summation of f into x, okay? Divided by the summation of f, which is basically the total. Now, the problem with these tables is, as you can see, I don't have one specific value of x, right? I have a range. So the solution every single time will be to find the midpoint. So the midpoint for this is 30, it's 50, and it's 80. Do we all get this? Do you see how this comes out to be? 60 and 100. The midpoint is 80. Okay. So after that, we have to multiply f and x, right? So basically multiply every single f with the values of the x. So 30. So the way we write this is f dot x. So 30 30s are 900, if I'm not wrong. 50 40s are, I think, is 2000, if I'm not wrong. And then 30 80s is 2400, if I'm not wrong. Okay. For the summation, I basically have to now add 900 plus 2000 plus 2400. And then in the denominator, I'm supposed to add these three numbers, okay? Basically the summation of f. So 30 plus 40 plus 30. So this comes out to be 100. So the top half comes out to be, this is 4400 plus 900, that is 5300. 5300 over 100. So these zeros get cut off, and this is 53 seconds. All good? Okay, wonderful. Complete the histogram to show the information in the table. So the histogram, this uses the concept of frequency density, okay? There's a formula for frequency density, which is basically FD, let's just write it on the left-hand side. So FD is equals to the frequency divided by the class width. Class width. What is the class width? Class width is basically these values, okay? The width of each class. And by class, they refer to these values, okay? I don't know why I used those. Let me just go back to them. Yeah. So these are my class widths. And these are my classes. And what else do I need? This is my frequency. Sorry, my bad. This is the frequency. And the class width is basically the gap between this and this. So this is 20, right? Because from 40 till 20, that's 20. And then from 40 till 60, that is also 20. So my class width is 20. For this, my class width is 40. So class width basically refers to the size of each class, okay? So let's make a table for this. Let's write F, let's write CW, referring to the class width, and FD. The formula for FD is frequency over class width, okay? So the frequency each time was 30, there was 40, there was 30. The class widths were 20, 20, and 40. So the first one will be 30 over 20, which is 3 over 2, 40 over 20, which is 2, 30 over 40, which is 3 over 4. You can already see that they had drawn this for you at 1.5, right? From 0 till 40. So the next one is from 40 till 60, right? And the class width is found for this was 2. So from 40 till 60, I'm going to draw this and join these, okay? And make sure you do this with a scale. My diagrams are not with scale, which is why it's going to be a bit, it's not going to be straight, but you have to draw very straight ones. The last one is 3 by 4, which is 0.75. And I draw this from 60 to 100. So this is my 60 mark. There's my 100 mark. 0.75 would be somewhere along here. So this is the last one. Any questions? I hope you know this formula. I hope you have understood how I came to this, and then the diagram for histograms, right? Yes?
So,
Yes, ask away.
could you redo question 13A? I got 47.
47. I think you've made a mistake in adding these up.
Okay.
Can you check?
Oh,
Yeah?
yeah, I added 900, 2400, 2400.
Yeah. Okay. Please make sure you're not using a calculator, because it's good practice that you solve now without a calculator, as your actual paper is also not going to have calculators. Okay.
Okay.
This session might take a bit of more time. I had initially planned 4:30, but I might need some time till 5. Is that okay with you guys? I'm going to provide you with the recording, hopefully. So if you have other classes, you can leave, but I'd highly recommend that you stay till the end. Okay. Also, just as a personal favor, I need a help from you guys. The help would simply be that, just a second. I would really request you guys, since we're almost near the end of our time and you might have to leave, please fill out this form just to express how much this workshop has genuinely helped you. Okay. Because I don't know if you know this, or if your parents have told you this workshop is entirely free of cost, so we're not charging you anything for this. The entire purpose of this workshop was just to let students know some information or some new things that schools often don't tell you guys, or tutors don't tell you guys. So we are taking times out of our schedule to help you with this, just out of your help, okay, just for your benefit. Okay. So we'd really appreciate some feedback. If you could tell us what were things about the workshop that you appreciated, or things that you feel like would have been better if you did some other way. So I would appreciate any feedback. You don't have to lie. You don't have to just be nice for the sake of it. If you feel like something should have been improved, please tell me that. Or if you feel like something I've done was really helpful, please feel free to tell me that as well. Okay. I'd really appreciate if you take like 2 minutes out of your time to fill out this form after the class or during the class right now, if you're okay with that. Okay.
Definitely,
So
sir.
okay, thank you so much. I really appreciate it. So the next part is frequency density, cumulative frequency graph. This is very easy, and I'd really like to skip through this because we have very limited time. Let me just tell you how to solve this. You basically have these coordinates. These coordinates will be x coordinates. These coordinates will be y coordinates. So 20 and 0, right? So in the x coordinate, I have 0, and I have 20 and 0. Then I have 40 and 12. So 40 and 12 is somewhere here. Then I have 60 and 36, 60 and 36 somewhere around here, 80 and 60. So that is 80 here and 60 here. 174, 100 is here, 74 is somewhere here. And then 120 and 80. So 120 is here and then 80 is here. And then I just join these lines. It's very important, very, very important that you draw this with a smooth curve, okay? You have to have a smooth curve. You can't have a curve that goes like this, or like, don't have a graph like mine. Just have a smooth curve, okay? Don't have lines like this. Have a very, very smooth curve. Take your time, draw it very slowly, and draw a smooth curve, okay? The next part of the question is basically going to use your graph. So the median, the formula for median is n over 2, where n is 120, okay? N is basically the number of total things that I have. So in this case, wait, I have actually 80 things. My bad. It's not 120. What you basically use is this value, the frequency value, okay? So the frequency total is 80. That means my n has to be n equals to 80. So this has to be 80 over 2, which is the 40, right? The 40th value. I have to find the 40th value, which means I go to the graph now. I go to the 40 mark. I draw a line at 40. And whatever my corresponding value is, which is basically this value, I'm going to find the value from the x coordinate now and write that. So in my answer, it is 62 seconds, okay? The lower quartile formula is n over 4. The upper quartile formula, if they ever ask for you for it, that's 3n over 4, okay? Just know this for the upper quartile. So n over 4, that's basically 80 over 4, which is 20. So 20, I go to 20. I choose this line. I draw a line here. And what I get is 46, I think. 42, 44, 46. Yeah. Sorry, I actually got 64 here. This is 64, and this is 46. 64 is because this is the second box, right? I can see there's just 5 boxes here, which means each box is 2. So this is 62, and this 64, 66, 68, 70. So this is 64, okay? So these are my 2 answers. Are you all cool with this? Okay.
Yes, sir.
The next question is very important in this syllabus. So this dot basically means it's a recurring fraction, or it's a recurring number, okay? recurring number. The way it works is you basically have 0.25 and you keep on doing this. Okay, that's basically what a recurring value means. It's just on 5, which means it's going to be repeated as 255555. Okay, does that make sense? If it was like this, 2 and 5, then this would have been 0.25252525. Okay, if I were to say 0.252 and then a dot here, this would have been 0.252222. I hope you understand what a recurring number now is. Okay, so how do you solve this math? It's a very easy format. It's a very easy template. I'm just going to show it to you, and I hope you can remember this. Okay, first thing you write is x is equals to 0.255. Just make sure you write one extra. You don't have to write so many. Just write one extra. Okay, and then multiply this with 10. Okay, so what you get is 10x is equals to 0. I actually get 2.55. Any questions? Then what you do is multiply this again with 10, and now you get 100x is equals to 25.55. Introduce one more 5. Okay, are we all good so far? All I did was introduce this formula, this expression, and then multiply it with 10 twice. Okay, so now what we have is two different equations. This is one equation. This is my second equation. Okay, are we all good with this? Can you please confirm real quick? Now we subtract this. The third step is, this is the first step. The second step, the third step is subtract. So what you do is 100x is equals to 25.55, and I have 10x is equals to 2.55. Let me just write this properly. There's a recurring number here, right? So recurring number here, recurring number here. So when I subtract this, tell me if you understand this. All the following 5 that would have been here and here, do they not get subtracted together? Do you see it? Right? So all I'm left with is really just 23. Right? So I have 90x is equals to 23. That's it. 0.00. The purpose of multiplying 10 twice was just so I could have two different expressions that I could entirely get rid of for all the recurring numbers, right? Now that I have this, it's very easy. It's just x is equal to 23 over 90. Now, even though you're not allowed to use the calculator, I'd still just ask you to check this with the calculator. So if you plug this in the calculator, 23 over 90, you should get this exact number, 0.25555. This is what you get as the answer, okay? So your method is correct. So the answer is 23 over 90. That's the answer. Take 2 seconds, write this down if needed, and you ask me any questions if you have it, okay? Do you have any questions? Seeing none, let's move on. Okay, lovely.
Oh, sorry.
The
Just left it.
next, no worries at all. Do you have any questions though? You don't, right?
No.
Wonderful. So the next question says that the diagram for 2x minus 1, write down the coordinates of the points where the graph crosses the x-axis. This is a very specified rule. At x-axis, y equals to 0. Similarly, at the y-axis, x equals to 0, right? So since the question says at x-axis, y equals to 0, I basically have to just see where I think this is all I have to see. In the diagram, I can just visually see this point, right? There's another point, like if you see, this goes on forever, this goes on forever. There's no other point where the x-axis gets touched. So this is 2, 0. Cool. There's also B1, where I don't have to show any method. As long as I write the answer, I should get the marks for it. Okay. The second part says, write down the equation of each asymptote. Okay. So I want you to write down a very basic formula. I want you to write this down and remember this. Okay. So this is called a reciprocal function. A reciprocal function is basically numbers involving this 2 over x, right? So reciprocal function The format for this is basically y is equals to a over x minus h plus k. Okay, can you remember this for me? This part, x minus h, gives me the vertical asymptote. This plus k gives me the horizontal asymptote. Asymp. Now the question says 2 over x minus 1. So it says 2 over x minus 1, right? So if you look at the graph now, if you compare this, x minus h is supposed to give me the vertical asymptote. So do I have a vertical asymptote here? It's basically x minus 0. So x equals to 0, right? There's my vertical asymptote. Do you see it? The second one is just this minus 1, which is this k, right? So since k is equals to minus 1, my horizontal asymptote is equals to y equals to minus 1. And I can also see from the graph, without any formulas, these are my two asymptotes. Any questions? Please ask it. Do any of you have any questions? This one and this one. Are we
Yes, sir.
all cool? Are we all good to go?
Yes, sir.
Yes, ma'am.
Okay, thank you so much. Let's see. The next part says, by drawing a suitable straight line on the grade, blah, blah, blah. Okay, so the purpose of this, the method of solving this is always try to get back to your original equation from the new equation that you have, okay? So I can see that if I simply find this, it's this, right? This is my original equation and the minus x. So 2 over x minus 1 minus x equals to 0, right? So if I take this to the other side, what I get is 2 over x minus 1 is equals to x. So this is one graph. This is one graph, right? Any questions with this? I already have this graph drawn here. See? I already have this graph. So all I have to do is now draw the other graph, which is just y equals to x line, right? Y equals to x line basically refers to this line, where 1 is for both values, 2 is for both values, 3 is for both values. And if I join this line, any questions? This is y equals to x. Draw this on the graph, okay? The question says drawing a suitable line. So I have to draw this line. And then I can see there's 2 points of intersections. One is minus 2, comma 2. Sorry, minus 2, minus 2. And the other one is 1, comma 1. Okay? So this has to be minus 2 or 1. Any questions? Quick. You have any questions? All good? Wonderful.
All good,
Yes,
sir.
sir.
Thank you so much. Let's see. The diagram shows a solid made by joining a hemisphere to a cylinder. So this is a hemisphere, the top one. This is a cylinder, and there is a base in the bottom, right? Read the question. I can just already understand the question. I don't have to read the question, but I really encourage you guys to read the question, okay? This is the radius given here, 6, and this is the height given here. The question asks from me to find the total surface area. So if I say the total surface area is equals to the hemisphere on top, so the surface area of the hemisphere, let's say, plus the surface area of this cylinder, right? Of cylinder plus this thing in the bottom, right? Because if you think of 3D shape, it has to have a baseline. So there's a bottom here. So there's the base of cylinder. Now here's the best part. If you go to your formula sheet, the thing that I was covering in the beginning, you're going to see I have cylinder, right? I have this. I have this. I don't have this actually. Wait, I don't. Yeah, I don't need this. Do I? I do actually. So there's that. And then I have this. Sorry. This is a sphere, right? So I have a hemisphere. I have a cylinder. And I have a circular bottom, right? So it's basically this. So let's go back. What I just found was that I have a cylinder, I have a hemisphere on top. So the surface area of hemisphere, as the formula sheet says, the sphere is 4 pi r square. But since it's a hemisphere, I'm gonna divide this by 2. Do you all understand this? A hemisphere is just half of a sphere. So 4 pi r square divided by 2, that's basically 2 pi r square. Plus the surface area of the cylinder. In the question, it already says that it's 2 pi r h. Okay? And the circular base here is just pi r square. Okay? So I consider this and this are the same thing. So 2 pi r h plus 3 pi r square. Any questions? Okay. If I plug in the values of 5 and 6 now, I'm going to plug in 6 in the radius and 5 in the height. So 2 pi, height is 5, and height is 5, and the radius is 6, plus 3 pi, the radius is 6 square. So this is 30 into 2, that is 60 pi, plus 36 into 2, that is 36, right? 36 into 2, that is, did I make a mistake anywhere? I don't think so. Okay, let's see. So this is 36 into 3, 36 into 3, that is 108 pi, okay? Are we all good so far? So this has to be 168 pi. The answer is 168 pi. The question says to give you answer in terms of pi. So I don't have to use any decimals or fractions. I can just give the answer in terms of 168 pi. Any questions? Shoot. Do we have any questions? Wonderful. Thank you so much. Let's move on. Let's clear some space. Okay. Find the value of blah, blah. This is entirely from indices. The base understanding in this, or the approach in this, is to take the inner number and try to find numbers to represent this with in terms of, let's say, prime numbers, or let's say numbers that I can basically use powers of. Okay. So the easiest way to do this is basically just think that 125 is 5 to the power 3. Okay. I know 5 into 5 is 125. Sorry, 5 into 5 is 25, and 25 into 5 is 125. Okay. So I'm going to write 125 as 5 cubed, and then I'm going to write this. If I have am to the power n, this basically writing amn. Okay. So it's the same thing as writing 5, 3 into 2 over 3. So this 3 and this 3 gets cut, and I'm left with 5 to the power 2. So the answer is 25. Any questions? Seeing none, the next thing we're going to learn is whenever I have a power in minus, I'm going to take it into the denominator. Okay. So this thing becomes 1 over 4, 5 to the power 2. Okay. So the next thing I do is, again, the same thing. I'm going to try to show this as a number of, as a power of something else. So I know 4 is to the power 2, right? 2 square is 4. So 1 over 2 square to the power 5 over 2, right? So again, 1 over 2 into 5 over 2. So this and this gets cut off. And it's the same thing as writing 1 over 2 to the power 5. Now, if you have practiced enough papers, by this point, you should have this memorized, that 2 to the power 5 is equals to 32. Even if you don't have it memorized, just find it in the exam paper. It's completely fine. So 2 into 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16, 6 to the 32. That is 32. So your answer here is 1 over 32. And that is basically your answer. Okay? I hope that is fine. Do any of you have any questions? Okay, thank you so much. Let's move on. Rationalize the denominator. So the way we rationalize the denominator is whatever is in the third form in the denominator, we just multiply that with a negative, and then we multiply both the numerator and the denominator with that. Do we all get this? Do you have any questions? We all get this. So let's try doing this. So this into, wait, let's just see. Wait, basically my pen ran out of charge once again. So let me just try doing this with a normal pen. Okay, so minus this divided by minus this. Okay, this comes out to be negative 9 root 3 divided by negative sign in front and root 3 whole square, right? Any questions? This then becomes negative 9 root 3. Please forgive me for this line. And this becomes negative 3. This gets cut off. The negative sign gets cut off. And I have a 3 here, right? So this comes out to be 3 root 3. Please ask your questions if you have any. Cool? Okay, let's move on then. The next part is, sorry. This is basically the answer. Just write this here. The next part is to expand brackets. Very simple. It's just basic algebra. Just don't make any mistakes, okay? So 5 into 1 plus 3 root 2. And then I have a minus root 2. Again, 1 plus 3 root 2. Basically, what I did was I have this here. I have this here. And I'm multiplying both of this with this whole bracket, right? Any issues with that? Sorry, not supposed to raise that. Okay. So if I expand this, I get 5 plus 15 root 2. I'm really sorry. I'm using actual pen instead of an Apple Pencil. So there's a minus root 2. And then there's a minus 3 root 2 into root 2. Any issues with this so far? Can you please ask your questions if you have any? We're almost done here. We'll hopefully be over by 5 p.m. I think your time. So far, everything is cool, right? You want us in the expansion? Okay, lovely. So I have, do I have anything else to see here? I don't think I do. Okay, so I have a 15 here. I have a minus here, as in a minus 1 here, basically. And then I have, okay, so this thing comes out to be minus 3 into 2, right? Because the root 2 and root 2 get multiplied to become plus 2, right? So my next equation is 5. This is plus 14 because the plus 15 and the minus root 2. So plus 14 root 2. And then there's a minus 6 here. Yes? So I'm left with 14 root 2 minus 1. The question said that this is the format. So C is a number and K is the coefficient of root 2. So my K has to be 14 and my C has to be minus 1. Are we all good with this? I'm really sorry for my sudden change in handwriting. It's because I'm using a pen and my actual pen ran out of charge. Let me just bring that back. Yeah. Okay. So we can go back to a normal handwriting. So write as a single fraction in a simple form. Again, the easiest chapter of this entire syllabus is the algebraic expression 1. Okay. All you have to do is just factorize. So 5a over 6 into 3b over a. This a gets cut off. There's a 6 here, a 3 here. This is 1, this is 2. So now I have 5 over 2 into b, right? The answer simply comes out to be, I think, 5b over 2, if I'm not wrong. Are you all cool with this? b over 2. Sorry. Okay, so the next part is There's a fraction here once again. So what we do with this is we take a common fraction now, common denominator now, of 4. So whenever I'm doing this, right, into 2 is 4. So the numerator also has to get multiplied with 2, okay? That's 2p. The 4 does not get multiplied with anything to get 4. It's just multiplied by 1. So the 3t will also get multiplied with just 1. Okay, so that's basically how we do it. Does anyone have any question with this? You can ask it if you want. So the answer is 2p plus 3t over 4. Same concept. Gotta take the common denominator. Again, so in order to get here, I had to multiply x plus 1 with this, right? So I'm also going to multiply x plus 1 with this. And then similarly for this, I had to multiply x minus 2. So I'm also going to multiply x minus 2 here, okay? So let's clear everything. So the common mistake here is often that students mess up this sign. So make this sign consistent. And then I have 3x minus 2. And then if you simply expand this, that this becomes 2x plus 2 minus 3x plus 6 over x minus 2 and then x plus 1. This comes out to be, so there's a plus 2 here, plus 6 here, that's a plus 8. There's a 2x and minus x, minus 3x, that is minus x plus 8 over x minus 2, x plus 1. Any questions? Quick. Yeah? Okay, wonderful. So let's move on. This one is for, I think, what do we call this chapter? Proportionality, I think. Rates of change in proportionality. That was the name of the chapter, right? So in this chapter, there's 2 types of proportionality. One is directly proportional. Directly proportional. And the other one is inversely proportional. The directly proportional basically says that y is directly proportional to x. This means y equals to kx. Okay? The inversely proportional says y is equals to 1 over x. Sorry, y is inversely proportional to x. That means y is equals to k over x. Basically, whenever you're introducing an equal sign, you have to get rid of the proportionality sign and introduce a k here, okay? That's basically what you're doing. Any questions? There's the only 2 formula from this chapter. So let's see. This is given. So y proportional to 1 over root x. This basically means y is equal to k over root x. Just the formula that I mentioned right now, right? So when x equals to 9, y equals to 2. Just plug in these values. X equals to 9, y equals to 2. So 2 is equals to k over root of 9. This thing becomes 3. So let's just write 3. Let me just write one more step, no worries. So 2 is equals to k over 3. Therefore, k equals to 6. Find the value of y when x is 36. This is not the end of the math. I've simply just found the formula. So the formula is now, instead of k, we write 6. Are we all okay with this? Can you raise your hands if you're okay with this? Thank you so much. So the next thing we do is y is equals to 6 over root x. And now the x is 36 as the question says. So we simply just plug in 36 here. 36. And we get a 6 over root of 36 is also 6. So y is equals to 1. Y equals to 1. Okay. There is another side to this. I don't think I have to write -1 here, do I? So since it's a root over, I don't think it's mandatory for writing +-1. But since it's also root over, and a root over can always be plus or minus, that means the square root of 36 could either be +6 or -6, right? So with that being said, it could either be 6 over 6 or 6 over -6, right? So let's just write a plus minus 1 here. Are we all okay with this? Raise your hand if you're okay with this, and I'll move on to the next part. Okay, lovely. When x is increased by a factor of 4, so this basically means x has now become 4x. The value of y changes by a factor of p. So let's see what y becomes into, okay? So that's basically py, okay? So let's see. The formula was y is equals to k over a root of x. So that now becomes 4x, right? As simple as that. Now I have to see, do I have any value given in the question? Let's see. Since I do not have any value given, when x is increased by a factor of 4, the value of y changes with. Okay, so let's just factorize this from now, okay? So I can see if I bring this, oh, I have a k given, my k is 6. And if I have a 4 here, I can write this as 6 over 2 root x, right? I'm simply just taking the 4 outside. This is basically 3, right? So that is 3 over root x. Do you get it? Are we all okay with this?
Yes, sir.
Okay, so now here's where most students get it wrong. They come to this stage and they lose track of what they're supposed to do. You're basically supposed to compare the equation that you started off with and the new equation that you have. So my initial equation of y was 6 over root x, and my new equation of y is 3 over root x. Can you tell me the difference between these two? Is it simply not into half? When my equation is halved, I get this, right?
Yes, sir.
If I tell you that the factor p is just half, do you get what I'm saying? You simply compare the new equation with the old equation and you see what you get. And that's exactly what I've done. Okay? Thank you so much. Let's move on. I think we are towards the end. I please request you once again, since this is entirely free of charge and we don't get anything from this, I'd humbly request you, please fill out the feedback form. It would really mean a lot to me and to our other tutor, Asraf. I believe you've done a class with him as well yesterday. We've been working a lot on these workshops just to help you guys, and I really hope that you fill up the form, okay? I'm also sick, if you can tell. So I'm taking a 3 hours workshop with a cracked voice. So yeah, thank you so much for filling up the form by just taking 2 minutes out of your time. Okay, I really appreciate it. So let's see. This graph tells me that there's an equation of y is equals to 3x minus x cubed. The graph crosses the x-axis at A, at O, and at B. I can see this visually. Okay, so let's see. The question now tells me find the x coordinate. Did any of you ask any question? I just heard a sound. No, my bad. So the question tells me to find the x coordinates, right? It's very easy. We know that at x-axis, y is equal to 0. So the equation was y is equal to 3x minus x cubed. Now that becomes 0 is equal to 3x minus x cubed. And if I factorize x from here, I get 3x minus x. I get 3x is equal to, sorry, just a second. Yeah, I get 3x is equal to, x is equal to x into 3x minus x squared is equal to 0, right? So from this, I should have, wait, I can factorize this even further, my bad. Do we not, let's just keep it at this, okay? So we have these 3 for now, right? So when you bring this here, what we get is x is equal to 0, as we can see this already. And then I also get 3 minus x squared is equal to 0, right? If I bring this to the right-hand side, I get 3 is equal to x squared. And then x is therefore plus minus root of 3. That's basically saying either root 3 or a negative root 3, right? So this value is something like plus 1.41, if I'm not wrong. And this is minus 1.41 if I'm not wrong. Okay, so my 3 values are x equals to 0, x equals to positive root 3, x equals to negative root 3. Okay, so let's have a look at the graph. I can see that I have 1 point here in the negative x-axis. I have 1 in the positive x-axis. So this has to be negative root 3, this has to be positive root 3, and this is 0, right? The question asks from the x coordinate of A. So this is negative root 3. X coordinate of B, this is positive root 3. Are we all good with this? Yes? Lovely. Do we have any questions? We're almost near the end, so you can ask questions. We have the time for it. No? Okay, amazing. Let's see the next question. Differentiate 3x minus x cubed. Do we know how to differentiate? For differentiating, all we have to do is take the power in front and then subtract the power from it. Subtract 1 from the power, okay? So y is equals to 3x minus x cubed. Whenever I have a number like this, just assume that my power of x is 1. So the rule remains constant for everything. So what I'm supposed to do is subtract 1 from here, subtract 1 from here. So I bring the 1 in front. 3 into 1 is still 1. So 3 into 1 is still 3. And then this becomes minus 1, right? So x to the power 0. Anything to the power 0 is 1, okay? Minus. Again, I bring the power in front. So there is 3. And then x. And there's a minus 1 here, okay? So this becomes 2. This has to be my equation. Or 3, 1 minus x squared. Regardless of how you write it, it's the same thing. And the way we denote this is dy over dx. There's another way of denoting this. If I write y, then y prime basically means differentiating y. Similarly, if I write fx, then f prime x is basically the differentiated version of this. Any questions? Can we move on? All good? Okay, thank you so much. Find the coordinate of P and Q. This P and this Q are the turning points. Do you all see it? There's a rule for turning points. There are names for turning points. This is turning point, a vertex, a stationary point, let's say maximum point, or minimum point. These are all names for the exact same thing, okay? It refers to this highest point or this lowest point. And the rule for this is dy over dx equals 0 at that point. So we've just found an equation for dy by dx. Let's use that. 3 minus 3x squared is equals to 0, right? So 3 is equals to 3x squared. I'm just taking this to this side to get rid of the minus sign. So x squared is equals to 3 over 3, which is basically just 1. Therefore, my x coordinate is plus minus 1. Because if I just wrote this, I get the same thing, right? Any questions? Can I say thumbs up if you have understood this, or you let me know if you want me to explain more on the dy by dx? Lovely, thank you so much. So again, I have to judge which one is plus 1 and which is minus 1. So I can see the P is on the negative axis of x, which means my minus 1 would have to be here. And then my Q has to be here, right? So plus 1. This is Q. Now we have to find the y coordinates. How do I find this? I have this equation given. So let's plug in minus 1 minus minus 1 cube. So minus 3, this is minus. Minus 1 cube is also minus 1. Do you know this? Did you know this?
Yes, sir.
Okay, lovely. So this makes out to be minus 3 plus 1, which is minus 2. So when I have x equals to minus 1, this becomes, sorry, minus 2, right? Yeah. Minus 1, comma, minus 2. Cool? Similarly, our equation is again this equation. And now we are going to plug in x equals to 1 for this point. So 3, 1 minus 3, sorry, not 3. This is minus 1 cubed. So this is 3 and this is 1. This is 2. That means the answer for this is 1, comma 2. So P was minus 2, Q is 2. Any questions? Good. Okay. Now I think we are towards. Is this the last question? No, we have 3 more questions. Wow. Okay. So how do you do this? Did you guys memorize any table for this? Do you happen to know the exact values of graphs? So I believe in your textbook or anywhere that you've learned the syllabus, this is also a part of the syllabus where you have to memorize some special values of tan. Oh, sorry, not tan only. You have to memorize some special values for sine, for cos, for tan. Okay? And you have to memorize the values of 0, pi over 2, I think pi over 4 as well. Pi over 4, pi over 2, pi over 3, pi over 2, 3 pi over 4, 3 pi over 2, and 2 pi. Okay? You have to memorize all of these values for all of these. Okay? The equivalent of these are, as in for degrees, this one is 45, this one is 60, this one is 90. I forgot to write pi. This one is 180. This one is, I think, 225. This one is, I believe, 270. And this one is 360. Any questions? Any questions? I think I missed another one in between. Here's 3 pi over 2. Okay, so basically you have to know all of these values. Please refer to your syllabus or your textbooks to find these. So you have to basically just use this one where I have to know tan pi over 3 or tan 60, the same value, okay? And it should be root 3. In the table, you should have this, okay? If you didn't know this, please refer to your textbook. Please refer to the book or any of the other resources that you have, and you should have a table like this, okay? So let's see the next question. 2 sine x minus 1 equals to 0. I have to equate this, I think. So 2 sine x equals to 1. Sine x equals to half. Therefore, x is equals to arc sine or sine inverse half. Similarly, in that table as well, I think one of you had replied that the answer for the previous one should have been half. It's actually not. In that table, you'll find for which value of x, our sine x comes out to be half, right? And it should be, I think, 30 degrees, okay? And then on the right-hand side, you should have another graph. Sorry, on the right-hand side of the table, you should find the second value of sine for which you also have the same value. It's 150 degrees. Let me show it to you in another way. So do you happen to know the 4 quadrants? Do you know this? So I know that for my sine, this line and this line, they both have the same value, right? Because they're both positive. So since this one was positive, we are going to take both of these values. Okay? Since this was positive, I'm going to take both of these quadrants. And I know from my table that this specific value is 30 degrees. So this is 30 degree and this is 30 degree. So the first one is 0 plus 30, which is just 30 degrees. The second one is 180 minus 30, which is 150 degrees, okay? Are you all cool with this?
Yes, sir.
Any questions? Okay. Last question. I think second last question, my bad. So in the diagram, OA is parallel to BC. OA, BC. OA, BC is equal to 3OA. So if OA is A, then my BC has to be 3A. Any questions?
No, sir.
We all get this? Okay. The second thing they say is M is the midpoint of AC. So what is AC? Let's see. Our A is here, our C is here, our M is here. It's already drawn. We don't have to do anything with this, right? So for the only information we've done is just find this. Perfect. So the next thing we do is the position vector. Do you remember what the position vector is? Position vector is when we compare the coordinates from origin, right? Position vector of B is B. We also note that this is already drawn in the diagram. Find the position vector of M. So for the position vector of M, we're basically finding this, right? From O to M. Now, the problem with this is I don't really know how to get from O to M directly, right? However, I can see that I can choose this path. Do you see it? So if I say OM is equals to OA plus AM. Is this correct? Now, the second problem with this is I don't necessarily know the value of AM. All I know that AM is the midpoint of AC. That means it's OA plus half of AC. Are we cool with this?
Yes, sir.
Okay. So now our new problem is, the second problem that you have, we don't know what AC is either, right? But I think we can find AC. How do we find AC? We basically start off at A and think, how can we get to C? Now, I know I can directly go from here to here, but I have no idea what this length is. So this has to be the wrong way because there's no point in finding this. That is basically what the question was, right? To find AC. So I have to find the value of AC using all the values that I know already. So I know this is A, right? This is positive A. So if I were to go from A till O, would this not become negative A? Do you see this? So the path that I'm going to choose is the reverse way from A to C. So I first go from A to O, then I go from O to B, then I go from B to C. Do you see it? So AC is equals to AO plus OB plus BC, right? AO, like I just said, is minus M, not A. Don't make this mistake, it's minus A. So this is minus A. Do any of you have any questions about why this is minus A? It's in the opposite direction. That's why. This is positive direction. And I'm going backwards. So this has to be minus A. Okay. And now I'm following the same direction as B. So it's going to be just plus B. And then we found BC, the first thing in the question. So this has to be plus 3A. This comes out to be B plus 2A. So we've just found out AC. And now we plug this thing here, right? Let's do that. OA plus half B plus 2A. And OA was A, right? We also know that. Sorry, not this. I wrote the wrong thing. So OA is basically just this. So that's A plus half of B plus 2A. So that is A plus half B plus just A, right? Because half into 2B to half into 2A is A. This comes out to be 2A plus half B. And if I want to write this together, then I just write 4A plus B equal to 2. Not necessary. These are both the same things, okay? This is both the same thing. So we just write the answer as 2A plus 0.5B or half B. The exact same thing, okay? Any questions? Okay, now we move to the last question of the paper. The line y is equal to 7x plus 3 intersects the curve. Very easy question. This is a quadratic equation. This is a line. Now, all we have to do is just plug this in, right? So y equals to y. That's the concept we have to use. So 7x plus 3 equals to x squared plus 5x minus 12. Are we all good with this? So let's bring the things here so that we can keep this positive. That's not a rule. It's just what will help us in the future. So x squared plus 5x minus 7x minus 12 from here, and then a minus 3, which is 0. X squared minus 2x minus 15 equals to 0. Do you know how to simplify this? Middle term breakdown, right? So I know 3 5s are 15. So x squared minus 5x plus 3x minus 15 equals 0. X minus 5 plus 3 x minus 5 equals to 0, x plus 3, x minus 5 equals to 0, x equals to minus 3, x equals to 5. We've just found out the x coordinates of both a and b, okay? X coordinates. Now we will use this equation, 7x plus 3. So what we know is y is equals to 7x plus 3. So we plug in 7 minus 3 plus 3. We get minus 21 plus 3, that is minus 18. And then we plug in 7, 5 plus 3, 7 35 plus 3, that is 38. So we have two coordinates. One is minus 3, minus 18, and the other one is 5, 38. Any questions? Yeah?
No, sir.
Yes, sir? Do you have any questions?
I said no, sir.
Okay, thank you so much. So our last and final answer of this paper is minus 3 minus 18 and 5, 38. Okay? I've just spoken for 3 hours nonstop, and this paper is not very hard, if you can imagine. You have to just practice enough times to make sure that you stop making common mistakes and you get the hang of the paper. With that big said, I think we can end today's class. We will have another session tomorrow for paper 4, the same time. I'm sorry for taking 30 minutes extra, but I really appreciate all the people who have taken your time to stay here till the very end. I also appreciate the people who have actively participated and you've let me know your issues or you've given me feedback. The last thing before we end the class, once again, I'm begging you. I'm really sorry for begging as well. Please fill out the feedback form by taking 2 minutes of your time. And I hope you will give us feedback. We also have a YouTube page. Let me just write it down for you. YouTube page is the same as the YouTube channel, is the same as the account's name. So that is Cambridge Fan Page. We're also on Facebook with the exact same name. It would be, we have a lot of workshops in that channel as well, but we'll be developing this over the summer. So since you're in IGCSE, hopefully by the time you're giving your AS and A levels, you will have way more resources in that channel and you're going to have way more workshops like this in the channel. Okay. I really appreciate all of you taking the time to get here and to give me 3 hours of your time by listening to me. I hope this has been helpful. If any of you need the PDF of this, please let your parents know and give, if you let your parents know, and if your parents give me the WhatsApp number or your email ID, then I can send this to you over email or WhatsApp, okay? I'll send you the PDF of this entire solved worksheet. So thank you all for joining. See you all tomorrow at 2 p.m. again. I hope that works. Yeah, you're welcome. Bye-bye. Take care. Thank you so much. You're all welcome. I really appreciate all of you coming. Thank you. I hope you have a good day as well. Bye-bye. See you all tomorrow. Thank you. Bye-bye.